Night hangs over the launch ranges, a velvet lid on a restless mind. Sodium lamps pool on concrete, generators hum, and somewhere a checklist is whispered in a voice that never rises above a murmur. The sky looks calm to anyone who has never measured it. On screens, the heavens are not serene at all. They crawl with uncertainties, pixels of possibility, numbers that refuse to sit still. Far beyond the reach of those lamps, an interstellar traveler slides through the dark, catalogued, tagged, and assessed with the cool precision of orbital dynamics. The verdict arrives with the comforting word that publics crave: harmless. Yet the rehearsal lights still glow, the tables still fill with printouts, and a slow ballet of readiness plays out in empty deserts and fluorescent rooms. The question forms in the air like frost on glass. If harm has been ruled out, why does the choreography of defense continue? Quiet, methodical, and unsentimental. The answer hides in the shape of risk itself, a shape that never looks like a straight line. A planet has learned to read. It reads its sky the way sailors once read the lips of waves at the edge of storm. When intelligence became a mirror, the species learned that the mirror reflects threat as well as wonder. The interloper that now carries the name 3, I slips across that mirror as lightly as a smudge. It will not touch the cradle, analysts say. It will pass, a fleeting echo of some torn nursery where other suns have their own winters and summers. Still, instruments keep their vigil. A beam of radar wakes, skates outward, and returns with a shrug of silence. The shrug is not a lullaby. It is a reminder that tools speak in probabilities, not promises. In the silence, there is room for drills, for simulations, for a choreography that calls up launch trajectories from sleep and sets them pacing the floor. Fear is not the engine that turns these wheels. Memory is. The sky has written its script into ice cores and myth, into clay and into bones. There have been cold seasons that arrived without asking permission, and there have been streaks of fire that ended stories and began new ones. To stand under that history is to understand the difference between panic and prudence. The language of prudence is preparation. It looks like a countdown clock that never reaches zero, like a bunker that houses data rather than soldiers, like a whiteboard crowded with equations that converge on a spectrum of outcomes rather than a single verdict. It is not a war in the ancient sense, though a warlike imagery clings to it because humans reach for the metaphors they inherited. This is a rehearsed conversation with momentum and gravity. It is a way to shape the future by being ready to place a thumb on the scale at the right second. The visitor becomes a story told in photons. Telescopes divide its light, measure its breadth, infer its spin from brightness that rises and falls like a heartbeat. The numbers add up to a path, then a corridor inside a corridor, narrowing as data decoheres into confidence. Confidence is a process, not a prize. The word harmless marks only a frame in a film that is still running. The frame is beautiful. It is not the end of the reel. Somewhere up the chain of communication, a press officer places that word into a sentence crafted to soothe. Down in the trenches of calculation, the same word is written with pencil, not stone. Pencils are for adjusting. If anything shifts, if a jet of gas sneezes from a sun-warmed scar, if dust lifts and sunlight pushes that dust into a tiny sail, new numbers will request new choreography. The difference between alarm and poise is simply that poise rehearses before the music changes. In the places that never make the headlines, preparations have their own quiet glamour. A mission controller watches a slow parade of skyfields, data stitched with timestamps that keep time zones honest. A chamber hisses as engineers test a thruster that may one day be asked to kiss a rock with measurable intent. A planner refines a flowchart that decides who speaks when conflicting models arrive at the same hour. A statistician runs tales of distributions until the tales filigree into lace. A fragile pattern that says rare does not mean impossible. A student, up too late with coffee and a stubborn streak, writes a script that will shave minutes off a radar processing pipeline, minutes that might one day become the difference between a faint smear and a resolved silhouette. None of it is dramatic to the naked eye. All of it is the skeleton that allows a species to move without panic. Words matter, and the word harmless does a great deal of work. It steadies the breath of households that should never have to learn orbital mechanics. It lets markets ignore the night sky for another day. It builds trust that professionals are on the case. Yet the same word, left alone, can breed complacency. The professionals know this. Harmless is conditional on assumptions, on models, on the fidelity of sensors that blink through weather, through dust, through human error. There is a humility in accepting those conditions. The humility manifests as practice. Practice looks like launch crews reading scripts aloud, like analysts timing how quickly ephemerides spread through networks, like scenario leads challenging assumptions with hypotheticals that are unfair on purpose. Not because harm is likely, but because likely is not the only category that matters when entire climates and continents are the stake. In the imagination of those who keep watch, the celestial visitor is not an enemy, it is a test. Not a test set by a teacher, but a test the species sets for itself. Can the mathematics of orbits be translated into logistics that work under pressure? Can caution coexist with awe? Can collaboration cross borders faster than a stone crosses the inner solar system? The rehearsal does not diminish the wonder of an object that has sailed unknown gulfs to appear in a small patch of sky above a warm planet. If anything, it dignifies that wonder by treating it seriously. The same hands that build instruments to dissect the spectrum of a wandering star also build contingencies to spare forests and rivers from the worst roll of the dice. A civilization that values its oceans prepares for rare waves. The same logic holds for the sky. Inside the quiet of a control room, a graph climbs and plateaus. The axes carry labels that speak a private language, but the shape is universal. It is the curve of confidence growing with time and flattening as the returns diminish. On that plateau, the word harmless becomes heavy enough to hold for more than a news cycle. The rehearsal does not stop. It evolves. The lessons learned under this visitor will be grafted onto the next. Tools will be sharper. Playbooks will be cleaner. Radios will have fewer dead spots. Teams will know each other's cadence, as musicians do after a long tour. This is how a species that appreciates its own fragility becomes one that takes stewardship as an identity rather than an emergency. The night thins toward dawn, the concrete cools. People who live their lives in daylight will wake to headlines that treat the sky as an afterthought, a curiosity nestled between other curiosities. Somewhere, a technician locks a door and checks a line on a clipboard. Somewhere else, a scheduler puts a green box around a date that marks another drill. The visitor sails on, untouched by the rituals below, ignorant of the meanings projected onto its indifferent hull. It is a stone, a snowball, a relic of elsewhere. It is beautiful for that indifference. The rituals are beautiful for the opposite reason. They are acts of attention. They say that life notices, calculates, rehearses, and, when needed, acts. The word harmless remains true inside that attention. It is made truer by the attention, given that attention hones the capacity to respond if truth ever falters. The sirens that whisper do not announce catastrophe. They mark the tempo of stewardship. Silent deserts and fluorescent rooms become theatres where responsibility is practiced until it becomes muscle memory. If anything ever demands more than practice, muscle memory may be what stands between a blue world and a sorrow it does not deserve. Until then, the visitor glides, the lamps fade, and the checklists return to their drawers. Readiness, not alarm, has earned another quiet night. The telescopes watch from volcanic shoulders where winds slide like cold rivers across lava rock. Their mirrors are modest by the standards of grand observatories, half-meter eyes built not for glamour but for vigilance. Each night they paint the sky into square degrees, a quilt of exposures stitched by an algorithm that never sleeps. The system has a simple mandate: find what moves that should not be moving. The cadence is relentless. Point, expose, shuffle, repeat. At the edge of dawn, a pattern ripples through the data stream. 3 points of faint light line up across successive frames, with a motion that does not match satellites or the casual drift of a near-Earth object. The software flags it. The pipeline does what it was designed to do. It subtracts the stars, measures the centroid, estimates the rate, and sends a quiet alert to the humans whose waking hours are pinned to the heartbeat of these machines. The instrument network was conceived as an early warning for imminent, ordinary danger, the kind that would brighten and swell on a collision track measured in days. Its lenses are wide, its depth is adequate, and its true power lies in repetition. That same repetition becomes a net fine enough to catch the unusual. On this night, the unusual looks like a dim smear near the noise floor of magnitude 21. The streak, so slight that it masquerades as chance, holds its course across 4 fields. It does not flash as tumbling debris might. It does not brighten as a flaring satellite would. It walks with the sky, but not with the stars. The observers accept the candidate and tip the schedule. Non-sidereal tracking takes over. The telescope follows the exact rate the algorithm suggests, sliding against Earth's rotation to hold the target still while the constellations crawl the other way. Astrometry is the art of humility. Every pixel is checked against the catalogue, every distortion term applied, to make sure the grid is honest. When the positions are submitted to the clearinghouse that lives at the minor planet center, the numbers look clean, the residuals behave. The provisional designation appears, a string of letters and digits that folds the candidate into a registry older than many careers. Within hours, other eyes swing to look. Panoramic survey mirrors on neighboring peaks, a university telescope on a dry ridge in the southern hemisphere, an amateur with an instrument as disciplined as any professional tool. Follow-up points trickle in, each one a stitch that tightens the thread of certainty. With 5 positions, a very wide corridor of possible paths exists. With 10, the corridor narrows. With 20, the orbit begins to confess what it is. The math of orbits is a conversation between gravity and time. When an object arrives bound to the Sun, its path is an ellipse, and its eccentricity sits below 1. When it comes unbound, the curve opens into a hyperbola, and the number climbs above that threshold. The early fits flirt with the border. The next wave of data pushes past it. The barycentric solution, which respects the pull of the whole solar system rather than only the Sun, points to an eccentricity that will not be tamed by observational errors alone. The inbound speed refuses to sit at 0 when measured at infinity. In the careful language of dynamicists, the excess velocity is significant. The word interstellar is not poetry here, it is a diagnosis. The registry will need a new integer, one that follows the 2 travelers already carved into the history of this kind of discovery. Photometry treats the faint smudge as if it were a conversation partner. Exposures stack, and the object sharpens enough to reveal a brightness profile that extends above the point spread function. There is a suggestion of a coma, slight and cool, a whisper rather than a shout. Color indices stumble toward the red, the kind of slope that prolonged radiation can paint onto a surface that has spent ages in the dark between suns. Spectra are hard to pull from something this dim, but even a crude spectrum can hint at a featureless continuum with perhaps a shallow absorption tucked into the noise. The team gathers what they can. Absolute magnitude is estimated with a caution that feels like respect. The size could be tens to hundreds of meters if it is dark, smaller if it reflects well, larger if it is cloaked in low-activity dust. Nothing locks down yet. Everything narrows a little. The logistics of confirmation look ordinary, which is to say they are the product of hard-won habits. Observers coordinate without drama. Time on larger apertures is requested and granted because the sky has a way of enforcing triage. Radar arrays search for a return that might be too faint this early, but the attempt is worth the effort. Infrared instruments look for heat that may not be there in measurable quantities, while the object still sits far from the energy of the inner system. Space-based surveyors add their eyes from above the atmosphere, providing measurements immune to weather and turbulence. Each piece feeds the orbit solution and the physical interpretation. None of the pieces alone can carry the weight of certainty. Together they begin to feel like a portrait. A name arrives as the confidence exceeds the threshold for a new category. The designation that starts with a numeral and a capital Y is a ceremony built on statistics. It marks the moment when the idea of an origin elsewhere becomes acceptable as fact rather than romance. The suffix honors the system that found it, a small nod to the discipline of wide-field vigilance. The telescopes are not sentimental. The crews are not either, at least not while the work is in progress. Still, There is a moment in every control room where the problem on the screen lifts its eyes and becomes a traveler from another Sunday. That moment changes the flavor of the night. It does not change the steps that need to be taken next. Trajectory specialists look upstream into the sky the object is falling from. They back out the asymptote, compare its direction to the flows of nearby stars, and ask whether the newcomer rides with the local standard of rest or cuts across it with a private velocity of its own. If it aligns with the galactic drift, it may be a seed tossed gently by the slow tides that lift material from remote reservoirs around other suns. If it arrives at an angle, it may carry the energy of a past close passage with a planet that gave it a kick, strong enough to break a home. Neither story can be proven with ease. Both sit comfortably within the physics of planetary systems. Worlds form, worlds perturb, and the small relics of those births are thrown outward into night. The cadence of observation shifts as the arc extends. Early targets of opportunity become scheduled blocks. The telescope network widens as observatories, at different longitudes and latitudes, contribute to a coverage that minimizes gaps. Calibration plans are rewritten to account for the object's changing phase angle, the way its reflective geometry shifts as it approaches and retreats. Photometric nights are guarded like oxygen. On marginal nights, the team will take what sky they are given and do so with gratitude. Software teams refine motion-matched filters to squeeze a fraction more signal from the background. The goal is simple: characterize without delay. A visitor like this does not linger. It will cross a slice of the system and be gone, leaving only data to hold in laboratories and mines. Public communication walks its own careful line. The word harmless belongs in the sentences that describe the path of this object relative to the blue world that watches it. The numbers support that. The perihelion distance and the minimum distance from Earth sit far enough away to keep nights calm. The designation does not change those facts. Interstellar does not imply danger. It implies rarity, context, and opportunity. It invites questions that are older than the species that asks them. How common are these wanderers? What do their surfaces remember? How does long exposure to cosmic rays write chemistry into ice and rock? The instruments cannot answer all of it, but they can nibble at the edges with honesty. At small scales, the discovery lives in habits. A technician tightens a bolt on a mount that should not shift a micron. A programmer comments code so that a colleague in another time zone will not stumble at 3 a.m. A dome operator checks wind speed against the limits of safe pointing. A graduate student looks at a light curve and asks whether a subtle rhythm hides a spin. The romance of a messenger between stars coexists with the prosaic discipline of care. That coexistence is a strength, not a contradiction. The universe rewards attention as surely as it rewards courage. By the time the sun rises on the islands, the cue for the coming nights has been rewritten. The small eyes will sweep their usual swaths with a new priority inserted like a page in a hymn book. The larger eyes will poo at atmospheric turbulence to scrape spectra from the edge of detectability. The net will hold. The visitor will begin to show itself not as a rumor, but as a set of measured properties. Size bracketed, albedo bounded, color placed in a family, orbit solved with residuals that drift toward the statistical floor. An object that began as a whisper becomes a voice clear enough to hear without straining, and the most astonishing fact in that voice is simple. It is not from here. Certainty begins as a line traced by a fingertip across a beach. Wind arrives, tide creeps, and the neat geometry softens into something truer. The mathematics of a newly found traveler looks crisp at first glance, a set of orbital elements that promise a clean clearance and a comfortable miss. Those elements sit on foundations built from pixels, timestamps, and star catalogues, each part carrying a quiet uncertainty. Combine them and an ellipse emerges in a 6-dimensional space, a shape that contains every admissible state of position and velocity. Project that shape into the future, and it becomes a corridor, a cone of possibility that narrows with good data and opens with the smallest neglect. The announcement spoken to the public favors a single number. The work inside the observatories lives with the corridor. The first correction arrives with parallax. Earth orbits. Stations stand on widely separated longitudes, and the apparent position of the object slips against the background with a rhythm that belongs to the observer rather than the observed. Accounting for that rhythm scrubs away a layer of illusion. The second correction arrives with atmosphere. Turbulence blurs, refraction bends, temperature gradients, and pressure profiles tilt the path of incoming light by fractions of an arcsecond. Those fractions matter when a distant body is faint and swift. Calibration frames taken against star fields of known positions let the software recenter reality, but the stars themselves are not fixed. Proper motions and color-dependent shifts contribute their own small biases. Every bias becomes a whisper in the corridor's ear. Astrometrists carry a discipline that looks like ritual. They weight each observation by its variance, reject outliers with methods that are stern rather than impulsive, and record the residuals that remain when the best fit has been declared. Residuals tell stories. If they scatter as they should, the model is healthy. If they trace a pattern, the model asks for something it has not yet been given. The covariance matrix that accompanies the orbit is not an afterthought. It is the living map of uncertainty, the way to translate new information into a tighter grip on the truth. Fold that matrix forward in time, and it stretches along the line of variation, the direction where uncertainty prefers to grow. The visualizations are beautiful, a ribbon through space that thins with every successful night and thickens with every cloud. Integration of the candidate path through the solar system is a tour of gravity's handwriting. The Sun writes the base script with almost all the ink. Jupiter edits with a heavy pen. Saturn, Earth, and Venus add marginalia that can be ignored only at the cost of accuracy. Numerical integrators step a solution forward in small increments, including the pull of these bodies and a suite of well-measured constants that would have astonished the astronomers of earlier centuries. Relativistic corrections polish the last place of the last digit when the object passes close to the heart of the system. The integrator's output is a future that diverges from the perfect ellipse in ways that speak to the presence of other masses and to the subtlety of precision itself. Observers prefer the discipline of clones. From the best fit and its covariance, they draw thousands of synthetic states, each one plausible given what is known. They cast those states forward, let gravity do its unsentimental work, and watch the cloud of possibilities evolve. If the cloud never intersects a sphere around Earth large enough to worry rational minds, the word harmless can be pronounced with a confidence that feels like solid ground underfoot. If a few clones brush that sphere's edge in distant years, the declaration must include a footnote that no press conference can comfortably hold. The footnote does not spell doom, it spells attention. That attention is the difference between a species asleep and a species awake. The line that delineates angular measurement and physical distance deserves its own meditation. A tenth of an arcsecond, at 1 astronomical unit, translates into 1,000 kilometers across the face of the corridor. The numbers are straightforward, yet they carry the drama of scale. A handful of measurements in poor seeing can widen a future miss by a continent. A night of exceptional clarity can shave the uncertainty until it fits inside a country. The world below these calculations has borders, cities, and memories. The world of the sky does not care about any of them. The corridor passes above them all without malice or favor. The duty of those who calculate is to make the corridor honest. Light itself complicates honesty. An active surface can blur the point spread function, displacing the apparent center away from the nucleus by a few pixels in the direction of a faint tail. As activity waxes with proximity to sunlight, the bias grows, and naive centroiding will record a trajectory that is not quite the trajectory of the mass that matters. Astrometric teams compensate with models that subtract the coma or by selecting frames and apertures that damp the bias. The gain is worth the patience. A corrected centroid can pull the corridor inward like a drawstring, preventing fool's confidence or needless worry born of cosmetic light. Time contributes its own character. Early arcs are treacherous because they invite overconfidence. With 2 nights, the geometry can masquerade as many things. With 5 nights, the masquerade slows, but does not end. With weeks and months, the masks fall, and the orbit steps into the open with the ease of a fact. The worst trap is a lull in coverage that lets uncertainty bloom. a week of weather on critical longitudes, a gap caused by a telescope that must rest, a moonlit period that drowns the faint. Each becomes a story about what could have been known sooner. No one loves these stories, yet they recur because the sky teaches humility even to those who already kneel. Planning grows from the numbers without fanfare. Schedulers carve out time around the changing geometry, favoring phase angles that separate the object from the glare of the Sunday. If an apparition will carry the visitor into southern skies, partnerships with southern facilities become precious. If the arc will only ever be long enough to sketch a passage and not a full biography, the teams accept that limitation with a grace earned by years of similar negotiations. The target does not negotiate. It moves. People must be the ones who adapt. Communication becomes a discipline of phrasing. The public hears a headline and needs it to be both true and simple. The professionals write reports that are true and complex. Between these poles lies a narrow path. Impact probability may be 1 in millions for a short window before it collapses to 0. That number can be shared without pageantry and without alarm. It can be explained as a product of extending a curtain into the future and measuring whether any fringe brushes the stage. When the curtain retracts, the brushing ends. The explanation holds the truth while refusing to be a spectacle. Certainty in this craft is not a switch. It is a slowly thickening fabric woven from nights, instruments, and motives that must remain clean. The clean motive is stewardship. The planet that receives these calculations is crowded with lives that need not learn the names of orbital elements to benefit from the care that those elements receive. The clean instrument is one that has been calibrated against its own tendencies toward drift. The clean night is a gift that cannot be demanded, only welcomed. Put them together, and the corridor narrows until it is as tight as reality allows. Fragility of confidence is not a weakness. It is a feature that keeps conclusions honest. A corridor that refuses to collapse to a line reminds its makers that nature answers to measurement, not to desire. When the final assessment speaks in gentle absolutes, those absolutes are earned. When the assessment must hold a sliver of conditionality, that sliver is respected. The mirror of precision never shows a face without pores. Those pores are the reason vigilance persists after the headline has settled. Eventually, the beach wind dies and the tide pauses. The fingertip draws a line again, this time with a steadier hand. A new night adds to the archive. The residuals quiet, and the ribbon of possibility narrows to something that can be held without slipping. The word harmless sits on this new line with a weight appropriate to the evidence. It is not a charm. It is a statement of what the best tools and the most disciplined minds can say. They say it with gratitude for the nights that allowed it, and with readiness for the nights that might not. Faint light curves begin to braid into meaning as nights accumulate. Photometry stitched across observatories reveals a rhythm in the brightness, a rise and fall that repeats just enough to hint at rotation. Period searches test hours against the data and land on a solution near 8 hours, with aliases that do not quite fit the later points. The amplitude is high, nearly a full magnitude, suggesting an elongated body, perhaps a ratio of 3:1 if surface reflectance is uniform. Uniformity is unlikely. Coma contribution softens the extremes, and even a thin veil of dust can hide shape beneath scattered sunlight. Analysts correct with coma models that subtract a radially symmetric profile, leaving a cleaner nucleus signal. The corrected curve still breathes in a tall arc, and the interpretation holds. This traveller is no squat pebble. It is a stretched relic, a shard or a spindle, turning steadily as it coasts between suns. Colour measurements resolve another piece. Through filters spanning the visible and creeping into the near-infrared, the slope is red, more so than typical stony asteroids but familiar to researchers who have catalogued dormant comets and D-type surfaces. Cosmic ray gardening and organics cooked by long exposure can paint this colour on ice, mixed with dust. A spectrum is harder to win, yet a few long integrations on large mirrors tease out a featureless continuum with a shallow drop near 1 micron that may be more noise than mineral. In gas, the classical cometry bands of CN and C2 hide below detection at the current distance. Nothing screams in emission. If volatiles are present, they remain shy in the cold. Thermal data add weight where optical light grows ambiguous. A mid-infrared instrument catches a whisper of heat that does not match a high albedo surface. The thermal flux, when combined with the reflected light, points to a low reflectivity and a size at the smaller end of earlier estimates. A nucleus a few hundred meters across becomes plausible, cloaked in a thin release of dust, invisible to coarse instruments but obvious to careful subtraction. The beaming parameter suggests a surface with modest roughness, not glassy smooth, not a field of deep pits. Thermal inertia appears low. Heat absorbs and re-radiates quickly, a behavior common to porous regolith and frost-coated rubble. Polarimetry draws out the grain size story. The degree of linear polarization changes with phase angle in a way that prefers submicron particles mixed with larger aggregates. Such grains scatter light with a delicate forward lobe, explaining the gentle brightening at small angles as the geometry swings. Polarization vectors align in a pattern that hints at a primary release region rather than uniform shedding. If a jet exists, it is not yet obvious in images, but the polarization map treats it as a rumor worth respecting. The dust is neither dense nor wildly abundant. A coma profile that follows a 1/ρ law at large radii becomes shallower near the core, a sign of sublimation close to the surface, or of radiation pressure shepherding the lightest particles outward. High-cadence imaging under excellent seeing reveals a faint fan offset from the antisolar line. Syndyne and synchrone overlays test the fit for radiation pressure acting on different grain sizes ejected at different times. The best match favors millimeter grains released days earlier with speeds of tens of meters per second. That is a quiet breath compared to flamboyant comets, yet it is real enough to enter models that predict the evolution of the surrounding dust. Projected into the plane of the ecliptic, the dust trace will never intersect the blue world in a dense sheet. A future meteor shower is unlikely. A mild enhancement at high-altitude radars might be the only terrestrial whisper if the tail ever grazes the orbital node, and even that would require a sympathetic geometry that appears absent. Radar arrays attempt to paint the nucleus with radiolight, self-sending a pulse and waiting for an echo shaped by the object's size and spin. The distance is unkind to this approach, and no echo rises above the noise. The non-detection is still useful. It sets an upper bound on radar cross-section that supports the small, dark nucleus estimate and argues against a metallic or bare rocky surface. If fragments circle the main body, they are too small or too diffuse to reflect in a way the arrays can bank. The sky keeps some secrets, simply because distance is a stubborn fact. Time series analysis of the light curve hints at complexity beyond a single spin. Small amplitude modulations ride atop the main period, moving in and out of phase like tides in interference. A tumbling state becomes a candidate explanation. Non-principal axis rotation requires a torque to induce it and a dissipative pathway to damp it. In vacuum, damping can take ages for a monolithic object. For a rubble pile, internal friction can settle chaos more quickly. The current state may record an ancient event, a collision, or a past period of vigorous outgassing in another system. If jets begin to strengthen under sunlight, the spin could evolve on human timescales, and observers resolve to watch for shifts that betray a changing angular momentum budget. Chemistry refuses to announce itself loudly in the gas. A space-based spectrograph shows a tentative absorption in the 3-micron region consistent with water ice mixed with refractory organics. At longer wavelengths, a shoulder near 4¼ microns nudges models toward a touch of carbon dioxide. No strong carbon monoxide line appears at this distance, though the sensitivity threshold leaves room for modest abundance. The low activity and cold state combine to muffle diagnostics. Still, even hints can guide origin stories. Water and carbon-bearing volatiles imply formation beyond a snow line around another star, followed by ejection during an era when giant planets or passing neighbors stirred the small body reservoir. The ratios, if ever measured cleanly, would fingerprint a nursery. For now, the fingerprint is smudged, yet the pattern prefers a cold birthplace. Dust production rates, calculated from AFRO, trace a gentle rise with decreasing heliocentric distance. The slope is flatter than classical comets discovered near Jupiter, steeper than essentially inert bodies on similar paths. The truth sits in the middle. The visitor is awake but not exuberant. Grain-sized distributions favor larger debris compared to the fluff of young comets. Radiation darkening and mantle growth through ancient cycles could explain the reluctance. Fresh ice may hide under a crust that fractures only when thermal stress opens seams. If so, activity could pulse rather than flow, inviting the surprise of outbursts that reset assumptions. Gravitational modeling folds these physical insights into the dynamical picture. A nucleus with low density and modest outgassing can experience gentle, non-gravitational accelerations that masquerade at first as astrometric noise. To guard against that trap, analysts incorporate a canonical A1 parameter along the Sun vector into orbit fits and test whether it reduces the residuals without overfitting. The improvement is marginal at this stage, and a conservative stance keeps the gravitational solution as the baseline. Close attention remains, ready to revise if future nights nudge the statistics into clarity. A radius of 100 meters moving with a density of 300 kilograms per cubic meter would feel a sunlight whisper strong enough to matter only when confidence already rests on fine margins. That regime has not arrived, but vigilance keeps the door unlocked. Subsurface considerations enter quietly through thermal models. Low inertia and slight activity suggest a porous matrix with icy pockets insulated by dust. Diurnal skin depths measured in centimeters keep the daily heat beat shallow, while seasonal depths measured in decimeters to meters will matter only as the object approaches its inner turning point. If a cavity connects to a crack, a plume can form, changing both the coma morphology and the torque on the spin state. Monitoring teams prepare image differencing pipelines specifically tuned to catch such geometry changes within hours of onset. A sudden fan, a new jet, or a kink in the tail would trigger a cascade of revised assumptions and follow-up requests. Risk assessments are updated with each physical constraint. Fragmentation probability is viewed through the lens of cohesion and rotation. A long body under spin faces tensile stress that increases with length and period. Current numbers keep the stress below expected cohesion for even weakly bound rubble, but a volatile-driven torque spike could change that calculus. Should a split occur, the fragments would share the parent orbit closely, spreading along the path rather than diverging into hazard with zeal. The main effect would be a brightening and a more complicated coma, not a sudden storm. That conclusion is provisional only in the sense that space cares little for human preference. The work proceeds with humility and with an eye for exceptions. Science instruments treat the traveler as a teacher that speaks in sparse syllables. Every measurement refines a character sketch, where shaded regions shrink and shaded possibilities whiten into exclusion. An elongated, dark, slightly active body with low thermal inertia and dust grains, favoring larger sizes, steps into focus. Coma asymmetries whisper about localized venting. Spectral hints lean toward water, ice, and heavier carbon species with reticent abundances. Spin may show a touch of tumble, a choreography that remembers a past violence or a long history of subtle torques. Each insight narrows not only the physical portrait, but the range of futures the object can plausibly write. Clarity emerges in degrees, and the emerging figure carries a presence both ordinary in physics and extraordinary in origin. Patterns tighten, then slip. A curve that looked obedient to sunlight begins to quiver with habits of its own. Residuals that once lay flat learn to drift in a single direction, then curl back, as if an invisible hand were pressing and releasing with no regard for the patience of equations. The explanation that first arrives is simple. Outgassing is waking, and the small thrust from escaping molecules is adding a nudge to gravity. The simplicity does not last. The direction of the nudge is fickle. The acceleration rotates slowly with the spin, then refuses to match any stable jet geometry. Models that assume a single vent fail. Two vents fare no better unless their strengths vary with a rhythm that cannot be pinned to a clean clock. The object begins to feel like a mood rather than a machine. Light curve watchers notice a second surprise. The period they teased from early nights slips by minutes, then by more. The amplitude shrinks on some rotations and swells on others, as if the viewing geometry were changing faster than angle alone can account for. Tumbling had been a suspect. Now it becomes a principal player. Non-principal axis rotation turns the nucleus into a lighthouse with more than one lamp, each lamp flickering as sublimation uncovers or covers facets of fresh ice. The dance between spin state and activity introduces feedback. A gust of gas alters the wobble. The new wobble changes which areas sunbake. The renewed baking opens a seam somewhere else. The torque moves again. The period change might be small on any given day. Across weeks it becomes a soft shuffle that no single model captures neatly. Dust behavior joins the rebellion. A fan that had held a steady place relative to the sun, even while the object slid inward, begins to fork. One branch leans anti-solar, another leans against the orbital motion, as if larger grains are defining their own loyalties. Syndine and synchrone maps that once sat comfortably atop the images now misalign unless the grain sizes are shifted to extremes and the ejection times are scattered. A change in gas composition could explain the shift by altering drag on the grains. The spectra give no loud confirmation. Without a clear tracer, dust becomes the diary of a chemistry that refuses to write legibly. A single night brings an outburst that clangs like a dropped bell in a quiet room. Brightness jumps by nearly a magnitude, holds for hours, then decays only part-way. The coma swells. The tail fattens. Profiles taken across the head steepen, then relax. The timing is wrong for a simple thermal trigger. The solar distance has not changed enough to justify a sudden flush. Structural change rises in probability. A crust may have cracked along a long hidden weakness. A pocket may have vented after centuries of being corked by cohesion and cold. The episode is too small to signify a full split, yet it changes the days that follow. Residuals get noisier. The spin becomes harder to pin. The corridor that had been politely narrowing pauses and considers widening again. A theory with quiet ambitions steps into the circle. The nucleus may be less like a baton and more like a flock. If the body is a cluster of bonded fragments rather than a single stone, then internal rearrangements can shift mass without obvious clues to observers. Even a slight migration of rubble within a weak lattice can pull the center of mass away from the center of light, as jets work their way through porous channels. The apparent position, if measured through a veil of dust, becomes a negotiator rather than a witness. Astrometric teams adjust techniques, using smaller apertures and careful coma subtraction to chase the true core. The improvement is real, but not complete. The flock theory retains its place on the whiteboard. Temperature models add a layer of difficulty. Low thermal inertia had suggested a surface quick to heat and quick to cool. A new fit to the thermal phase curve hints at patches with higher inertia beside patches with very low values. Mixed terrain forces a mosaic of behaviors. Slow warming plates hold heat into local night, supporting sublimation hours after sunset. Frosted hollows flash to life with dawn and quit by noon. Different rhythms of gas release mean different thrust directions at different moments in the spin. The integrated effect over days is a bias that refuses to be smooth. The object begins to look like weather rather than a calendar. A whisper about radiation pressure enters the conversation. Small fragments shed during the outburst might be large enough to carry brightness, but small enough to feel sunlight as sail rather than lamp. If a cloud of centimeter-scale debris shares the near-nucleus environment, the light curve could drag behind the mass by just enough to mystify. A gentle halo of brightness would shift the centroid a fraction of a pixel in the direction of the sunday. Under certain geometries, that shift can masquerade as a non-gravitational tug in the same direction. The fix for this lies in data scarcity. Only the sharpest nights can separate the nucleus cleanly. Sharp nights do not arrive on command. Dynamical clones respond to these uncertainties in a way that makes planners inhale more deeply. The center of the distribution remains where it should, far from any corridor that would bring harm. The tails gain fuzz. A smattering of simulated futures wander into narrow, resonant interactions with larger planets that tweak the path by amounts too small to matter now, but large enough to perturb later predictions if non-gravitational forces remain. Capricious. Future encounters are still remote and still safe by any rational standard. Yet the sensitivity to modeling choices grows, and with it, the appetite for more data and better fits. An idea with a narrow throat and a wide belly takes shape. The activity might be seasonal, in a way that does not simply follow solar distance. An obliquity near 90 degrees can turn one hemisphere into a long twilight, while the other bakes under a low Sunday. If the long twilight preserves delicate frosts, then a handful of days in a special geometry may release a disproportionate surge. The geometry does not repeat often. It tips into and out of existence as the nucleus precesses. The surge is not large enough to threaten mass or trajectory wildly. It is large enough to break simple assumptions with annoying ease. Groups that maintain color cameras report a texture in the coma undetectable in grayscale. Slight color gradients appear along the tail, bluer near the core and redder downstream. The change is exactly what one expects from size sorting and solar processing, yet the slope changes with a timing that does not quite align with observed outbursts. Invisible microbursts might be a culprit. Cavities release a puff barely bright enough to register in integrated light, while still adding fresh, bluer grains near the head. The pattern then ages as those grains are pushed away. The net effect is a color wave that washes across the coma with its own calendar. Radar remains quiet because distance remains unkind, but optical speckle techniques on very large mirrors flirt with resolution. A contour emerges that suggests extreme elongation, perhaps even a contact binary, two lobes touching at a neck. If true, torques from irregular outgassing could twist the system with leverage that multiplies small forces. A neck is a natural choke point for activity. When sunlight falls just so, gas could funnel through and create a jet that rotates with a different phase than jets elsewhere. The body becomes a chorus, not a soloist. The music is not chaotic. It is polyphonic. In the background of these puzzles lives a straightforward truth that refuses to comfort. The data set is finite, and the physics is complicated enough that multiple explanations can fit with similar grace. Bayesian fits can assign weights to each narrative, yet the priors are shaped by experience gathered in a system that is not this one. A traveller from another nursery carries habits shaped by a history no one here watched. That history holds details that would explain the current complications with a sentence, if only the sentence were known. Instead, teams accept a posture that mixes confidence in what is measured with patience for what is opaque. The mystery deepens not through shock but through accretion. One night adds a bend to a residual plot, another tilts a period by a few seconds, another paints a faint filament on the edge of a coma. Each is trivial in isolation. Together they argue that the object does not wish to be simple. It will be mined for understanding by methods that honor detail. Forecasts will be written with wider margins, because the margins are honest. The label harmless can survive this deepening because distance and energy still conspire towards safety. The label easy does not survive. The path through uncertainty becomes less a corridor and more a canyon with walls carved by subtle forces. The maps must learn the new terrain while the traveller keeps moving, indifferent to the cartographers below. Explanations gather like instruments in a dim pit before a performance. Each is tuned to a different key. Each answers to a particular physics, and none alone promises a full melody. The traveller invites models that are both conservative and bold, because the phenomena at play hide behind distance, faintness, and a history written under another Sunday. The theories are not decorations. They are tools for thinking, sketches of cause and effect that can be tested against light and time. In the sketches, small forces acquire a kind of grandeur. Momentum leaves clues no matter how softly it changes, and tiny impulses can braid together into paths that surprise. One path begins with seasonal jets. A body with high obliquity presents long twilights to some terrains and long noon to others, so sublimation can surge from bands rather than from a global skin. A vent that awakens at dawn and rests by afternoon will impart a daily torque, and if several vents hold different rhythms, the torques sum into a pattern that drifts with precession. The nucleus would behave like a weather vane with a personality, not a metronome. Light curve shifts, small changes in spin rate, and a nudge in trajectory along the sunline follow naturally from this picture. The strength of the idea lies in its compatibility with unremarkable ice and dust. Its weakness lies in the fine-tuning required to match the observed irregularity without invoking more exotic chemistry. Another path follows a change of phase hidden in the ice itself. Amorphous water ice can lock away volatiles in its irregular lattice for ages, then release both gas and heat when warmed past a subtle threshold. The transition to a crystalline state frees trapped molecules and supplies energy to push the flow faster, so a modest rise in temperature yields a disproportionate gust. Such gusts can build with little warning and decline asymmetrically, producing outbursts that lift larger grains than steady sunlight would normally liberate. The same process can open fractures as pressure grows in cavities, so the geometry of vents evolves as the material inside chooses a new structure. The physics is old, the application is fresh, and the signature would be a coma that swells faster than expected without strong gas lines to announce the culprit. Supervolatile reservoirs add a colder note. Carbon monoxide and carbon dioxide can sublimate at distances where water sleeps, giving a nucleus a gentle thruster long before it glows as a classic comet. A patch fed by buried CO, or CO2, can hide beneath a crust that releases gas through a sieve of pores. If dust is coarse or well cemented, the gas escapes without dragging much brightness with it, and the push becomes visible in dynamics before it becomes obvious in images. The resulting acceleration is smooth on average and irregular in detail, because pore networks act like valves that open and close as grains settle. The silence of spectra at long wavelengths would not rule this out if the supply were meager. The geometry of the coma would lean toward faint fans that refuse to shout. A quiet idea with a romantic pedigree looks to hydrogen made by radiation. During a long interstellar crossing, cosmic rays can split water molecules and leave molecular hydrogen trapped in the ice. Warming can coax this hydrogen to escape without carrying dust, and the push, though tiny, applies cleanly along jet lines that are nearly invisible to ordinary diagnostics. Such release could continue after activity from other volatiles has waned, creating an acceleration that persists even as the coma thins. The elegance of this notion lies in its economy. It explains force without light. Its burden is the need for just the right production and retention history during a journey no one saw, followed by just the right leak rate under sunlight. Dust itself can act as an agent rather than a passenger. Fractal aggregates produce large areas with very little mass, so radiation pressure tugs them with disproportionate zeal. If a halo of such fluff surrounds the nucleus, the combined brightness can shift the optical centroid away from the true center of mass by fractions of a pixel. That shift, when unwittingly used for astrometric fitting, masquerades as a non-gravitational acceleration. The effect strengthens near the sun and weakens far out, so a season of data might attribute to the nucleus what belongs to a cloud. The remedy requires resolution or filters that weight the inner core differently, and even then the fix may be partial because halos do not hold still. Inside that same halo, temperature gradients across individual grains can drive drifts by photophoresis, a force that pushes from warm to cool in a gas. It is gentle, yet laboratory work shows that millimeter grains can feel it strongly when the ambient gas is rarefied and sunlit. Near a weakly outgassing nucleus, the combination of photophoresis and radiation pressure can tilt dust streamers into shapes that mimic changing jets. What looks like a vent turning on and off could be a balance of forces inside a cloud of floating sand. The nucleus remains the engine, the coma becomes the transmission, and the car leaves tracks that do not map one-to-one to the throttle. Electrostatic lofting adds another avenue for surface change that requires little gas. Sunlight and the solar wind charge grains and ground differently across the day, and at sunrise the potential can lift dust from the skin, especially at the lips of pits, where fields concentrate. Lofted grains may saltate, leap and settle, and that dance erodes fresh surfaces while armoring others. The process is quiet in light but loud in consequences if lifted grains unblock a narrow vent or expose a pocket. The cadence would be tied to local dawn and dusk rather than heliocentric distance, a signature subtle enough to hide inside other rhythms. geometry might be doing more work than anyone prefers. A contact binary, two lobes joined by a slender neck, focuses gas flows and stresses along the join. When sunlight angles across the neck, just so, emitted molecules funnel along a curved path, turning torque into a function of phase angle in a way that confounds simple spin models. Seasonal change in which lobe presents more area creates long beats in the torque record. Small shifts in the orientation of the long axis relative to the sun, perhaps driven by weak Yorp torques, can then modulate the vents in a loop that never quite repeats until the geometry cycles through a long processional arc. Inside the body, granular physics carries weight that often goes uncelebrated. A rubble pile breathes under acceleration, with grains sliding into voids, arches collapsing, and the center of mass sloshing by centimeters to meters. Any rearrangement changes the moment of inertia, which changes the spin without external torque. The wobble adjusts, the lighting pattern shifts, and vents aligned to stress lines find their apertures altered. In a laboratory, this is the Brazil nut effect, where larger pieces rise slowly under vibration. In a comet, the name does not matter. What matters is that interior rearrangement feeds back into the forces a model attributes to jets, and small shifts in mass distribution can look like a change in thrust direction when no valve has turned. Thermal radiation itself can push and spin. The Yarkovsky effect is weak for objects shrouded in coma, yet an elongated nucleus with patches of low activity could still emit more heat in the afternoon than at dawn, inching its path sideways across years. The Yorp effect, which modifies spin through asymmetric re-radiation and reflection, can be amplified by small topographic features and by albedo patterns laid down by frost and dust. If repeated over long arcs, Yorp and sublimation torques together can sculpt a complicated spin evolution, one that drifts slowly until a vent crosses a threshold and a new regime begins. Mechanical failure supplies the punctuation marks. Thermal gradients raise stresses, ice contracts and expands, and the brittle crust between voids becomes a fabric stitched too thin. A crack races, the pressure in a cavity drops, and a plume erupts that throws off a spray of coarse grains. The event leaves a new geometry behind, perhaps a stepped scarp or a widened throat, and future sunlight plays a new composition on the same instrument. This picture can explain an outburst that refuses to return to baseline, because the structure itself has changed. Meteoroid impacts could trigger similar episodes, not by their momentum, but by waking a section already near a threshold. A more distant speculation mentions a fragment made largely of nitrogen ice, a shard torn from the surface of a distant dwarf planet by ancient impact. Nitrogen sublimates at temperatures low enough to drive acceleration without heavy dust, and the blue shift in its tail would hide modest emissions under glare unless instruments are lucky. The obstacle here is survival. Such a shard would erode quickly in repeated close passages, so a viable example would need a recent ejection and a path that kept it cold until now. The idea is not impossible, only demanding, and its clean prediction is strong acceleration coupled to weak color change. No single narrative commands the stage. A hybrid carries the most credibility. Localized jets modulated by obliquity, pockets of ice transforming and venting, a rubble interior adjusting itself, and a halo of fluffy dust biased by sunlight can act together to produce forces that slide the path while smudging the astrometric center of light. Small Yorp torques can whisper into the spin during quiet stretches, then be drowned by gas when venting resumes. The traveler becomes a system rather than a thing, and the system responds to sunlight through many channels at once. Each channel can be calibrated with patience, and patience can turn speculation into inference. Speculation is not guesswork in this craft. It is a disciplined compass that points toward tests. The models make promises about how light should curve, how colors should drift, how fans should tip, and how residuals should respond when vent strength changes with the angle of the sunday. These promises can be invited to keep or break themselves under watch. In the keeping and the breaking, knowledge advances, and the small forces that sculpt the path reveal themselves as partners in a dance that a patient planet can learn to read. The laboratory of a planet extends from deserts to orbits, From cryogenic chambers to machines that stare across the black, the traveler becomes a syllabus, and the syllabus is taught by instruments that speak different dialects of light and force. On mountaintops, silicon grids turn photons into numbers with an efficiency that would have felt like magic to earlier centuries. The cadence of wide surveys provides breadth. The patience of narrow instruments provides depth. Together they form a nervous system that feels its sky with eyes instead of fingers. A camera tuned to speed follows motion that the stars do not share. Its clock is trained to the rhythm of sidereal time, then broken deliberately so that a faint smear can be held still while the constellations slide. In this mode, magnitude becomes negotiable. Signal grows by stacking and by weighting, and weighting is orchestrated to avoid the globe of light that rises when the moon grows fat. Pipelines subtract the familiar to reveal the strange removing catalogues of stars until the frame belongs to the visitor alone. Precision is the currency. Calibrations knit nights together so that a change of 1/10 of a magnitude has meaning rather than whim. Infrared instruments listen for heat that sunlight writes into surfaces, and the thermometers they carry are spectral. They map emission into temperature and temperature into size through models that account for roughness, rotation, and porosity. A whisper in the mid-infrared can be more honest than a shout in the visible when reflectivity is low. With that honesty comes ambiguity that can be pried open only by combining bands. A larger, shinier body can masquerade as a smaller, darker one if color is ignored. Instruments on board orbiting observatories dodge clouds and turbulence, filling gaps that ground-based systems cannot cross no matter how valiant. Polarimeters add angle to intensity. They measure not only how bright something is, but how that brightness lines up in the plane of the sky. Dust grains impose an order on light. The order reveals the size and texture of the grains and the geometry of the scattering. With those clues, a tale turns from sculpture into process. Bluer cores and redder wings become evidence rather than decoration. Between angles, the degree of polarization curves with phase in a way that fingerprints composition. It is a quiet tool, but quiet tools often hold the deepest patience. Spectrographs tease apart color into its ingredients. Gas has lines, each line a rung in a ladder electrons climb and descend. Dust has slopes and broad troughs where molecules shake and bend. Instruments chase these signs through optical windows and through the longer waves where molecules announce themselves more clearly. Some lines hide under glare, unless integration times stretch and noise behaves like a trained animal. Patience earns a profile of volatile release that can be cross-checked with models of sublimation. A faint absorption near 3 microns might become a dossier on ice, not because the feature is strong, but because it sits where physics says water should testify. The dossier grows as additional wavelengths join the ensemble. Not all knowledge arrives through light. Occultations deliver geometry with the drama of a curtain drop. When the traveler crosses in front of a star and blinks it off for a heartbeat, stations scattered across continents record the instant the light falls and the instant it returns. Each chord sketches a straight cut across a silhouette no instrument can resolve under ordinary nights. Combine many cuts, and a shape emerges without an image, a negative hand pressed into a sheet of time. Organizing these campaigns is a feat of logistics. Clocks must agree. Telescopes of all sizes must cooperate. The reward is a contour that tightens models of size, tilt, and spin with an authority few other techniques can summon. Radar offers an echo where distance will allow it. A powerful transmitter casts a pulse that returns, sculpted by the target's size, relief, and rotation. Range and Doppler spread translate into dimensions and periods, and surface roughness writes an accent on the echo. This is a rare privilege for targets that come near, and a vanishingly faint blessing for those that stay far. Even a notection can constrain reflectivity and rule out certain materials. The discipline of radar invites dreams of future arrays designed to reach farther, building planetary biographies from radio light even when sunlight refuses cooperation. The atmosphere of the traveler is a laboratory too small to visit but large enough to model. Gas molecules collide, carry dust, and break under sunlight. Monte Carlo codes release virtual particles into virtual space and ask them to obey real physics. Outflows from vents are turned into jets with specific opening angles, speeds, and mass fluxes. Dust sizes are drawn from distributions that mimic shattering and sintering. The synthetic coma is rendered into images that can be compared with photographs from telescopes. The match is never perfect. The parameters that get the tail correct make the head too bright, and the ones that fix the head starve the tail. Each miss teaches. The next model listens. Dynamics has its own engines. N-body integrators walk the orbit through the pull of major planets and lesser masses, using steps that keep energy balances honest. Uncertainties travel with the trajectory like shadows, represented by clouds of cloned states that span the admissible. If small pushes from gas affect motion, those pushes are parameterized and tuned to minimize the leftover noise in positions recorded by astrometry. A good fit is never allowed to be a great fit unless its parameters make physical sense. The penalty for overfitting is seductive success. The wiser choice is a fit that leaves behind a remainder the world can believe. Laboratories on Earth practice the physics that distance hides. Vacuum chambers cradle frozen mixtures of water, carbon dioxide, organic tar, and mineral grains. Lamps mimic sunlight at intensities scaled to solar distance. The mixtures crack, puff, and slump in slow motion under cameras that never blink. Jets carve pits, crusts grow. Dust lofts with startling ease at local dawn when fields of charge flip. The experiments are imperfect analogues, yet they supply a table of behaviors that field astronomers can reach for when an outburst or a color wave surprises a survey. The familiarity that results is not a replacement for data. It is a way to keep imagination disciplined. Technology marches toward larger ambitions. Survey telescopes with eyes as wide as city blocks prepare to sweep the sky with nightly completeness, turning object tracking into a reflex of a civilization rather than a feat of a few observatories. Infrared missions plan to measure heat from the vantage of space, cataloguing dark bodies that betray themselves only by their warmth. Small spacecraft designs are drafted to sprint toward targets with cameras and dust counters the moment a rare traveler is flagged, trading grand capability for speed and focus. Trajectories are pre-computed. Launchers are booked in principle. Checklists sit inside drawers, waiting for the right phone to ring. Planetary-defense folds these tools into rehearsals. Simulations of decision-making run with data streams mocked up to mimic a difficult apparition. Who requests radar time? Who drafts an occultation prediction? Who writes the alert that asks dozens of small telescopes to step outside their normal programs? Success is measured in hours saved and in egos that learn to collaborate under time pressure. The timelines reward clarity. A script that places the right numbers in the hands of the right desks before a day ends becomes a line of defense more effective than any dramatic image. Precedents from kinetic impact tests inform the doctrine while remaining separate from immediate observation. A nudge delivered to a small body altered its orbit by millimeters per second and its cloud of debris by more. Those numbers migrated not as weaponry, but as calibration. Momentum exchange behaves with dignity when planned. Energy disperses into fragments that brightened telescopes around the world and then faded into memory. The lessons translate into confidence that intervention is a technical rather than mythical act. They also translate into humility that every object is idiosyncratic and that no single method belongs in every playbook. Analysis does not end when the object fades. Data archives hold exposures in which the visitor was faintly present before anyone knew to look. Reprocessing those frames with fresh ephemerides extends the arc backward, turning weak glimpses into strong anchors. Pipelines mature, too, with algorithms that learn from errors. Centroids are corrected for coma better. Photometry is adjusted for color terms more carefully. The next traveler benefits from the stubbornness of this one, not in a metaphorical sense, but in metadata and code. Communication tools belong in the kit as surely as spectrographs. The discipline of writing clear reports that describe uncertainty without drama is a technology of its own kind. Visualizations translate covariance into ribbons of possibility that non-specialists can see without learning the grammar of matrices. Confidence intervals are plotted as shaded lanes rather than as numbers in tables. Diagrams of the solar system are drawn with geometry that does not lie. When trust is built on explanations that avoid mystique, cooperation improves. Observers in one hemisphere answer calls from another, with more enthusiasm when the picture is clean. All of this labor folds into a posture that treats the sky as a partner. The traveler is not an adversary, not a herald, and not a toy. It is an object moving under physical laws that are patient enough to be learned and sharp enough to punish sloppiness. Instruments make the learning possible. Simulations make the learning portable. Drills make the learning durable. The planet does not sharpen swords. It sharpens pencils and lenses and protocols, believing that preparation is a kind of love for a world that is both small and brave. Rooms with no windows hum like held breath. Clocks line the walls, set to times that disagree on purpose. A map of the inner system glows on a screen large enough to feel like a tide pool of light. Around the table sit people who have learned to keep their voices steady when numbers are not. They call these meetings exercises, rehearsals, simulations, coordination drills. The furniture and the tone resemble strategy sessions that once centered on terrestrial conflict, yet there is no enemy here, only a moving problem and the responsibility to be ready for it. A scenario opens with a set of coordinates and a date. The parameters are crafted to be plausible. A minor body is discovered at the edge of detectability. The arc is short. The corridor of possible paths brushes the Earth within a few months. Impact probability begins near zero and rises as the fits converge. Nothing is certain except the need to choose what to do next. Roles are assigned. Observers request time on instruments. Analysts run orbit determination with fresh weights. Communications leads prepare messages that can travel from science desks to public ears without losing the truth in translation. Agencies practice speaking with one voice while keeping the science appropriately cautious. A second scenario plays out a different difficulty. The object is large enough to matter but fainter than expected. The reason is not specified at the start. Maybe it is dark. Maybe the phase angle is unkind. Maybe the crust absorbs sunlight like a sponge. Space-based infrared assets take a turn, their detectors drinking heat rather than light. The exercise measures the speed with which thermal data can be reconciled with optical photometry to bound size and albedo. The answer delivers mass, and mass decides whether any intervention would be feasible. Here time is a currency, and the ledger rewards hours saved from indecision. The tables host more than scientists. Emergency managers arrive with laptops full of evacuation patterns and shelter capacities. Logistics officers bring charts of launch windows. Legal advisors remind everyone that skies cross borders, and so do consequences. Public information specialists practice drafts in plain language that respect the public rather than patronize it. The cadence of these gatherings has been refined by hard lessons from other kinds of crises. Clear roles prevent duplication. Clear data prevent rumor. Clear ownership prevents the paralysis of too many hands reaching for the same lever. Thresholds are printed on one page, like a set of commandments. If the probability exceeds a small percentage at a given lead time, a particular set of actions becomes mandatory. If the corridor crosses certain latitudes, a specific set of ground assets are alerted. If the object brightens beyond a defined magnitude, spectrographs with reserved contingency time pivot without debate. These triggers are built from long arguments distilled into policy. They are not shackles. They are a way to let tired minds do the right thing under fluorescent light when adrenaline misbehaves. A simulation day will often introduce a twist. Observations from one hemisphere are interrupted by weather. The object's light curve points to a rotation state that complicates radar ranging. A spectral hint suggests an active surface that will alter the trajectory ever so slightly over weeks. The twist forces teams to use the redundancy that the system was designed to contain. Telescopes in the south pick up the slack. Clones and covariance maps are updated twice as often. Communications are rehearsed with more care because uncertainty has widened. The surprise is always realistic. Space prefers to be inconvenient. A quieter set of screens tracks technology readiness. Spacecraft teams maintain a matrix of missions that could be adapted or accelerated. A small interceptor bus with a simple camera and a dust counter sits on a shelf as a design, not a hardware reality. A list of launches sits next to it with windows and performance estimates. The idea is not to launch on rumor. The idea is to know what can be done if a target demands a look from up close. Time spent on these matrices reduces the temptation to improvise under pressure later. Improvisation may be romantic, but it breaks easily. Instruments are not the only tools. Protocols are refined with the same care as mirrors. Who calls whom when a probability crosses a line? Which agency drafts the first global alert? What language goes into the first paragraph to calm without sedating? The social physics of trust matter as much as Newton's equations when hours are expensive. Email lists are updated with redundancies. Secure channels are tested. Voice bridges are scheduled and then unscheduled to see whether people can improvise in both directions. Drills measure not only accuracy, but latency. A simulation cannot breathe without an audience. Representatives from partner nations sit in, sometimes in person, sometimes as faces in small rectangles on a screen. Data rights are clarified. Sharing agreements are restated. The spirit of these sessions bends toward openness because the sky refuses to be proprietary. No one owns the corridor of a rock that moves at kilometers per second. When the public eventually hears about a real event, trust will travel along the same cables that carried rehearsal messages. The continuity matters. Impacts are modeled with software that knows geology and atmosphere. For a given size and speed, the code produces footprints with varying damage depending on entry angle and material strength. Planners overlay these footprints on population maps and infrastructure networks. The result is not fear, it is triage. If a rural region lies beneath a fragmenting airburst, the danger is broken windows and stress injuries. If a dense coastline lies beneath a shallow angle entry, the hazard includes shock waves and tidal anomalies triggered by ocean entry. These differences drive decisions about who to call and what to advise. Intervention scenarios are the least frequent and the most sober. A kinetic impactor is modeled as a transfer of momentum that subtracts a small velocity component from the target. The magnitude of that subtraction is a function of the impactor speed, mass, and the poorly known efficiency factor that depends on how much ejector leaves and in which directions. The timeline for building and launching such a vehicle is measured in years, not months, and the exercise acknowledges that truth. The practice here is about deciding early or deciding not at all. Waiting forever is indistinguishable from declining under a different name. Gravity tractors are discussed as a slow hand laid on a shoulder. A spacecraft flies alongside the target and uses its own mass and thrusters to tug gently for months to years. The method is elegant and patient. It is also only viable with long warning and with targets that are cooperative in shape and rotation. Nuclear options are never treated as a first choice. The physics offer raw power. The politics and the uncertainties about fragmentation impose caution. Exercises that include these choices are designed to teach when to close those doors as much as when to open them. The most important metric in these rooms is not accuracy alone. It is honesty about uncertainty. Plots of probability are displayed with shading that reflects both what is known and what is not. When a new observation tightens the corridor, the shading changes in real time. Participants practice narrating these changes aloud. They avoid the trap of speaking as if the last decimal place were stable. The art lies in making humility feel like strength. That art takes practice, and the practice takes place here, under light that never changes with the weather. Ethics sits quietly near the end of the table. Who bears the risk if a deflection fails? Who decides which region absorbs the reduced probability after a nudge moves a strike point across maps? These are questions without comfortable answers. The drills do not pretend to resolve them. They force them into the open so that silence cannot be mistaken for wisdom. Philosophers and lawyers attend not as decorations, but as voices who know that technology without consent can become a new kind of hazard. When the day ends, reports are written as if they documented a real crisis. Timelines are listed. Bottlenecks are highlighted. Recommendations are assigned owners with dates. The tone is dry because the work is serious. The absence of smoke and sirens is a blessing, but it is never used as an excuse to be lax. The next exercise will implement a handful of these recommendations and invent new stressors to keep the system awake. This rhythm has become part of the culture inside planetary defense offices and observatories alike. Inside the quiet, a visitor from the sun hangs above the table in soft light. Its path curves around a glowing sphere and returns to the darkness. A small annotation notes a minimum distance, a margin wide enough to permit sleep. The room acknowledges the margin by closing laptops and walking out into sunshine or night. The tools will wait. The reports will be read. The scripts will be updated. The practice will continue because practice is the simplest antidote to dread. Somewhere else on the planet, a telescope will open in the dark and begin its own service, unrelated to meetings and yet connected by purpose. The room is empty now. The screens return to their default skies. The decision trees hang on the wall like diagrams of a forest no one has had to enter. Preparation is the only victory available in a world that shares space with rocks and ice and trajectories that are indifferent to hope. The victory is quiet. It tastes like order in the face of chance. It asks nothing from anyone who did not volunteer. It exists so that if a day arrives when numbers point toward a narrower lane, the response will feel like breathing rather than panic. A small spacecraft once crossed paths with a small moon and turned theory into a measurable change. The scene was simple in mechanics and profound in consequence. A camera guided a block of instruments toward a sunlit speck. Pixels thickened into a boulder field. The image froze. Telemetry cut to silence as metal met stone at kilometers per second. Minutes later, telescopes on many continents and in orbit watched the aftermath write itself into light. The orbit of a moon around its parent had shortened by an amount that made the breath catch. Momentum had moved. The idea that a fragile machine could place a thumb on a celestial scale had graduated from mathematics to a line drawn in the sky. The plume that followed told its own tale. Sunlight lit a fan of debris that stretched into a thin tail. Radiation pressure combed grains into streamers that changed shape with time. A small companion carried by the impactor flew through the wake and sent images of a cratered surface briefly turned into a fountain. Later, deeper analyses would show that the ejector contributed more push than the impactor alone. The target donated energy to the deflection by throwing material out in a preferred direction. Momentum enhancement changed a clean problem into a richer one. What mattered to doctrine was not the exact efficiency. What mattered was that the method worked better than the naive case. Stone could be nudged with finesse, using physics that multiplied the effort in a favorable way. This experiment became the kernel of a playbook. It showed that precision guidance could land a strike within meters on a target seen only as a cluster of light until the final minutes. It demonstrated that autonomy on board could handle the last-second choreography when no human could intervene. It proved that a mission designed for a single act could serve a purpose that rippled across institutions. The point was not to smash. The point was to measure the change, and to learn how materials respond when hit with great speed in a low-gravity environment. The answers were specific to that one target, yet they offered the first real calibration point for a broad class of bodies. The aftercare of that act is still unfolding. A European probe is on a journey to map the scar, weigh the moon, and test models of internal structure with instruments that listen to gravity while they hover and circle. 2 small companions will fly with it, one carrying a tiny radar to probe the interior, the other hosting a spectrometer to read the surface, and a camera to track dust. Together they will read the crater rim and the boulder fields with a patient eye. The purpose is to turn an impulsive change into a long lesson that feeds the next design. Crater size will be tied to impact, angle, and speed. Ejector mass will be tied to density and cohesion. The textbook will grow a new chapter based on measurement rather than argument. While kinetic impact becomes a practiced language, a second language is being built in the dark parts of the spectrum, where heat is easier to find than reflected light. A survey telescope in space will stare in the infrared, mapping the small warm dots that betray a vast population of near-Earth objects regardless of how dark their surfaces are. Its detectors will see bodies that ground-based surveys struggle to hold, especially those lurking inside the glare where the sun hides dangers from twilight observers. From these maps will come sizes rather than guesses, and size is the key that unlocks mass and energy. With mass in hand, The question of whether to nudge or to watch becomes a calculation instead of a fear. On the ground, a giant eye with a fast blink is nearing full stride. It will image the entire visible sky every few nights, with a depth and cadence unmatched by any survey before it. In the data will be arcs of motion that link faint points from night to night, assembling new asteroids from an ocean of stars and galaxies. The pipeline will need to be as strong as the glass. Machine learning will highlight streaks that human eyes could overlook. Orbit solvers will turn reports into ephemerides within hours. The harvest will be relentless. The catalogue will swell. The unknowns will shrink. Between low Earth orbit and the edge of space, a handful of radar facilities will continue to paint echoes off near visitors whenever geometry allows. Ranging will refine distances by orders of magnitude compared to optical methods alone. Doppler spreads will reveal rotation rates and shapes in outline. In special cases, paired facilities will work together to build delayed Doppler images that sketch craters and ridges into maps. A good radar pass turns a shadow into a portrait. A single portrait can collapse a corridor of uncertainty in ways that plots on paper simply cannot accomplish. Taken together, these capabilities begin to look like a doctrine. Find what matters early. Measure size and spin without romantic assumptions. Model how a nudge would couple to structure. Act only when action stands on a foundation of data. Each step feeds the next. Discovery is not a trophy. Discovery is the opening move in an analytic chain that leads either to confidence in inaction or to a timetable for intervention that leaves time for engineering to be done with calm hands. In this doctrine, testing has a special place. A civilization cannot ethically wait for a crisis to discover whether its tools work. The kinetic test created a precedent for trying a deflection in a controlled environment. Future tests might refine slow pull techniques by flying beside a cooperative asteroid and gently tugging long enough to register a change. Even a few millimeters per second would show up in a careful orbit fit after months. A demonstration of this type would teach the art of proximity operations around a lumpy spinner, while also producing data on a method that carries elegance for long warning times. The survey in space is part of the same rhythm. By moving the primary discovery engine above the atmosphere and into thermal wavelengths, the search will find bodies that would otherwise go unseen. Those bodies include targets on interior orbits that approach from the sun side, as well as dark objects that ground-based surveys could pass over during bright lunar phases. The promise is not just a longer list. The promise is a list with biases understood and corrected. Once bias is tamed, risk can be ranked in a way that deserves the name ranking. A deeper benefit flows from the culture that forms around these tools. Teams that build impactors share checklists with teams that build telescopes. Survey scientists coordinate with engineers who think in thrust and delta V. The conversations teach patience and remove the glamour from panic. A playbook becomes less about heroics and more about schedule. Launch windows are calculated. Decision points are set on calendars. Messages are drafted long before they are needed. The romance of crisis yields to the quiet diligence of stewardship. Public understanding is part of the machinery. After the impact test, images and timelines reached people who would never read a dynamics paper. They saw a human-made machine draw a white square around a distant stone and guide itself into a precise end. They learned that the change in a moon's period was measured by watching light and shadow alternate on a graph. The simplicity of the explanation served not to trivialize the work, but to dignify it. When a future survey issues a notice that a new object will pass at a safe distance, the memory of that demonstration will lend strength to the word safe. Across agencies, the flow of data is becoming a utility rather than a favor. Alerts move along standard formats. Ephemerides are posted to services that anyone with a telescope can reach. Coordination is practiced until it is routine. The result is a fabric that flexes under stress rather than tearing. When a rare traveler appears that asks for attention in a narrow window, the fabric will hold. It will hold not because any one tool is perfect, but because the tools have been taught to share burden. Everything comes back to a single requirement. Knowledge must arrive early enough to matter. The impact test shortened a moon's orbit by a modest fraction. If a similar fraction were applied to an asteroid years before a potential encounter, the missed distance would grow to a comfort that maps could display with a wide brush. The survey in space will make the years available. The eyes on the ground will fill the gaps. The radar dishes will draw hard edges on shapes. The follow-up spacecraft will turn model parameters into measured facts. Each part multiplies the value of the others. The doctrine is not a tower. It is a network. There is no glamour in rehearsing a method designed never to be used in anger. That is precisely why it must be rehearsed. A species that writes its name into landscapes with roads and rivers is now writing footnotes into celestial mechanics. The notes are small. They are measured to many decimal places. They speak of caution and courage married in the service of a world that has learned to think beyond seasons and election cycles. Kinetic missions and infrared surveys are not arrows and shields. They are ways to place knowledge in front of danger and to reduce danger by amounts that look small in equations and large in the lives they protect. Some night soon, a heat-seeking telescope will add another point to the growing catalogue. Some day after, a ground-based mirror will catch the same point in reflected light and fix its motion. A radar will ask it to speak and hear only silence, yet the silence will narrow a parameter anyway. If the object is interesting enough, a meeting room will glow with plots and probabilities. The playbook will open with familiar pages. The end will be a line in an archive that reads safe. The line will owe its quietness to a chain that includes a crater on a tiny moon and to a set of eyes that see warmth in the cold. Fragility wears a veil of grandeur in the cold. A small body turning in sunlight looks serene from afar, a dim bead gliding along a precise curve. Inside that bead, voids lace through dust and ice. Grains cling by vanishing forces, and stresses collect in silence until a seam parts. Fragmentation has its own vocabulary. Thermal gradients raise hairline fissures, where dawn follows night by minutes. Rotational spin inches toward a threshold as jets trade momentum with space. Tides from a close pass by a massive body coax rubble into sliding avalanches. None of these needs to be dramatic to be decisive. A quiet crack can reorganize an entire nucleus. When cohesion fails, the geometry of risk changes instantly. One target becomes many, and the swarm obeys rules that differ from the parent. Large fragments inherit the path, keeping to a narrow ribbon, while smaller pieces feel sunlight more keenly and drift like seeds on a faint breeze. Dust becomes a fluid in slow motion, poured into a tail by radiation pressure and into trails by gravity. The result is a filamentary cloud that thickens and thins along the orbit, a lace that can persist for years. Modeling such a cloud requires more than orbits. It requires granular physics, sublimation, and photometry wrapped together, because brightness does not track mass linearly, and mass does not travel as light suggests. Within the atmosphere of a planet, the difference between a stone and a swarm is the difference between a hole and a flash. A compact rock can carve a tunnel of fire and reach the ground with energy still coherent. A fragile body tends to burst, converting kinetic energy into shock in the air. Altitude decides damage. A break-up high overhead rattles windows and startles birds. A break-up low over a city leaves a ring of glass and a thunder that takes minutes to fade. Strength matters as much as size. A meter-scale monolith can outmatch a 10-meter foam of frost and dust. The metrics used by planners carry uncertainties multiplied by composition, porosity, entry angle, and speed. Upper air is not the only stage. Fresh debris sheets can intersect the orbit of satellites that skim the ionosphere and those that sit in geosynchronous rings. A millimeter fragment at tens of kilometers per second delivers more energy than bullets made for earthbound wars. Shields of thin metal and foam, designed to spread and soften impacts, can handle a background rain. A meteor storm is not a background. Operators rehearse safe modes that turn panels' edge onto the stream and shut down non-essential surfaces to reduce cross-section. The sky does not promise warning for such storms unless surveillance of parent trails is diligent and geometry is kind. Fragmentation also complicates illumination in a more subtle way. A cloud of small fragments brightens the coma, shifting the center of light away from the center of mass. Measurements anchored on brightness can be coaxed into false testimony about where the nucleus is and how it moves. Correcting for this requires careful image processing and assumptions about grain-size distributions that can rarely be proven outright. A single embedded pebble with unusually high albedo can pull a centroid by more than a statistician would prefer. In a crowded environment, the truest point is sometimes the dimmest. Inside the rubble body that has not yet failed, stresses accumulate in patterns that are not intuitive. Thermal contraction at dusk tightens bridges between grains, while expansion at noon pries them apart. Jets create local thrusts that compress here and relieve there, lacing the interior with plates of stress that rotate with the spin. Cohesion in such a body is a patchwork of van der Waals forces, sintered contacts, and ice that has partially welded grains. When a failure finally runs, it can select the path of least cohesion rather than the path of greatest stress, producing odd splits that leave one lobe smooth and another jagged. Observers will later search for the logic in the silhouettes. The logic lies inside. If a body parts into a chain, each bead begins its own weather. Sunlight falls on surfaces that were interior an hour earlier. Sublimation wakes along fresh planes. The chain can develop a hierarchy of activity where smaller pieces become brighter per unit mass than their parent. This amplifies the radiative forces they feel, which speeds their divergence. In extreme cases, the chain can become a spray. The spray writes a meteoroid stream into space that will harden into a predictable ribbon only after the gas disperses and the orbits settle. Until then, density along the path is patchy and forecasts wobble. Tidal fields add another script. A pass near a massive world stretches the small body along the line to the center, easing grain against grain until arcs collapse and slides begin. The failure need not be complete. Lofted material can fall back, armoring the surface with blocks that change the thermal balance. Regions once bright become dark, as boulders blanket ice. The altered albedo feeds back into temperature and sublimation, which in turn affects spin. The next approach arrives with a new personality written onto the skin. Each cycle is a lesson in how closely mechanics and chemistry are intertwined when gravity barely holds. Atmospheric entry physics is a theater of ablation and pressure. A fragmenting body presents more area to ram pressure, raising temperatures quickly and spreading heat across surfaces that erode by layers. Stagnation points glow, then strip away to reveal fresh material that flashes again. The breakup altitude depends on strength, but once the cascade begins, momentum spreads laterally and the shock front fattens. Energy deposition follows a profile that peaks and then trails, a pulse that can be reconstructed by infrasound and light curves recorded by all sky cameras. These reconstructions teach planners how to map damage footprints and how to estimate yields from brief flashes on daylight skies. Dust trails are archives of tearing. The distribution of grain sizes in a meteoroid stream carries the memory of the fragmentation epoch. A dominance of larger grains points to cohesive breakup with limited shattering. A wealth of small grains hints at energetic venting or brittle failure in an icy matrix. Streams age under planetary perturbations and the slow drag of radiation forces. Their nodes precess. Their widths inflate. Occasionally, geometry gifts a planet with a storm, thousands of meteors per hour scratching parallels across the night. Beautiful is not the same as harmless. Pilots report glare and turbulence near the brightest events. Observatories adjust their schedules to spare radiant directions saturated by streaks. Spacecraft face hazards that are less spectacular and more practical. Optical surfaces lose contrast as tiny pits evolve into scattering centers. Panels coated in fine dust absorb heat and run hot, shortening lifetimes. Gimbals and mechanisms designed for decades must resist grit that never sleeps. Engineers answer with filters, baffles, and covers, and by orienting vulnerable components away from predicted streams when possible. In deep space, where cover is a myth, shielding takes the form of layered foils that vaporize an impact into a plasma that spreads the blow. No one promises perfection. The promise is resilience through redundancy. Fragment clouds themselves can be simulated only with compromises between fidelity and tractability. Hydrocodes model the first instant of rupture. the pressure waves that race through pores, and the splintering of weak junctions. After milliseconds, the problem belongs to N-body integrators that follow hundreds or thousands of pieces as they earn their own orbits. Gas drag is important at first, then negligible, then important again when outgassing from fresh surfaces resumes. Radiative forces whisper continuously, adding drifts that widen the cloud in predictable ways. The trick is to hand off between regimes cleanly so that energy and momentum balance without artifacts. Each improvement in such codes borrows from experiments in vacuum chambers and from case histories written in sky data. Where human safety is concerned, the most worrisome corner of parameter space is not the largest bodies but the ones that are large enough to carry significant energy and weak enough to break low. Their footprints can be as wide as a city, their windows of arrival short, and their precursors faint until late. Risk assessments focus on lead time as much as yield. The tools that serve discovery and tracking are tuned to pick such bodies out of noise. Infrared surveys excel when albedo would deceive. Rapid cadence optical sweeps excel when motion is fast and phases are unkind. The goal is to keep surprise on a leash. Even in the absence of an encounter, fragmentation in deep space matters because it fertilizes the near-Earth environment with streams that alter the background risk of small impacts. Climate models of the upper atmosphere incorporate dust influx to understand noctilucent clouds and radiative budgets. Satellite collision risk models include seasonal spikes associated with known trails. Ground-based radars that measure meteor flashes contribute statistics that guide design margins for shields. Fragility thus becomes a global parameter, a number folded into spreadsheets far from telescopes. Across all these threads runs a single theme. The fury of debris is not a counterpoint to fragility. It is its consequence. Weak bodies write strong signatures when they fail, and those signatures interact with a planet across altitudes and technologies. Measuring the weakness, modeling the failure, and anticipating the products are not exercises in pessimism. They are the means by which quiet nights remain common and surprises remain stories that end in relief. In that work, a shard of ice and dust becomes a teacher whose lessons can be hard, but whose curriculum is essential. Decisions arrive as quiet thresholds printed in ink and rehearsed in minds long before any alarm sounds. A corridor on a screen carries a shaded band of possibility. Beside it, a list of triggers waits with patient authority. If the uncertainty shrinks below a defined fraction, begin radar calls. If the minimum distance falls within a band measured in hundredths of an astronomical unit, wake the infrared assets. If the impact probability exceeds a small, stubborn percentage at a stated lead time, convene the full table. The list is not theatrical. It is a contract between evidence and action. Hazard must be translated into language that many hands can lift. Scales compress messy inputs into simple bins, colors that signify attention levels, numbers that compare a future risk to the background rain of small impacts that have always fallen. One scale addresses public clarity with steps that climb from negligible to noteworthy to alarming. Another speaks to specialists by comparing a candidate event to an average year in probability and energy, expressed as a logarithm that prefers humility. The exact boundaries are policy as much as physics. Their value lies in consistency. When a rating nudges upward, instruments pivot without argument. When it falls, the pivot reverses with equal grace. Observation thresholds keep the night from becoming a scramble. A minimum arc length is written into the plan, not as a ceiling for confidence, but as a floor for prudence. If the fit to sky positions clears this length and the covariance tightens to a prescribed ellipse, the status changes from interesting to operational. That single word moves requests to the front of queues, unlocks contingency time on telescopes, and authorizes high-cadence imaging that would have been too expensive in minutes yesterday. Another threshold watches residuals. If they lean systematically along the sun line, orbit solvers switch to models that allow non-gravitational terms and report both fits side by side until one earns trust. Radar plays by its own thresholds. Signal to noise must cross a line, or echoes a superstition. Geometry must allow the beam to sweep the target within a window, narrow enough to make calendars matter more than weather. When the conditions match, a page in the playbook lights green. The transmitter schedules a pulse plan, the receiver readies delay and Doppler maps, and the community waits to see whether the echo will collapse uncertainties by orders of magnitude. If the pass fails by hairbreadths, a different page lights amber, instructing observers to extend optical coverage because the missed chance now raises the value of every photon. Occultation campaigns live by predictions that must be tight enough to lay a moving shadow across a set of telescopes, spaced like teeth on a comb. A threshold on ground track uncertainty governs whether the comb is worth building. If the band is too wide, the page remains closed and time is saved for better nights. If the band narrows, a volunteer network mobilizes within hours. Strings of small apertures set out across highways and fields, clocks synchronized to fractions of a second. A single blink can turn a mystery into a silhouette. The threshold turns logistics into science. Mission design thresholds begin with time. If the lead time is shorter than the build time for hardware under ordinary budgets, the matrix shifts from space intervention towards civil protection. If the lead time clears a year count that can carry an interceptor or a scout, another branch opens. Pork chop plots are drawn, contours of departure date against arrival energy. Launcher performance tables meet propulsion tables, meet mass budgets. A color sweeps across the contour to mark feasible windows. A second color marks windows that are not just feasible, but practical under fiscal and political limits. The green light for design studies is not a cheer. It is a signed order to calculate until margins are honest. Within design, thresholds multiply and promote discipline. Navigation requires a predicted ephemeris, with uncertainties below a set number at the intercept epoch. Autonomy requires a visual magnitude that a guidance camera can hold in frame during terminal approach under expected phase angles. Structural analyses require confidence that target cohesion sits within a bracket, because a too fragile body may swallow momentum into spray that flies the wrong way. Each requirement spawns a verification plan with its own gate. Clear the gate and move. Miss a gate and pause without shame. Communications, thresholds, protect trust. A draft bulletin is prepared when a candidate crosses a low bar on significance, written in plain language that explains probability, energy, and timeline. It sits in a drawer until the bar rises again. When it rises, the bulletin leaves private servers for public feeds without a scramble that invites error. If the bar declines later, a second draft is already composed to explain the decline. The sequence preserves dignity. Correction is framed as progress, not contradiction. This restraint is part of readiness. Legal and diplomatic thresholds govern the moment when a mission that alters orbits moves from blueprint to request. If a deflection would transfer risk from one region to another during the maneuver, a consent process begins and cannot be skipped. If the maneuver touches launch or overflight agreements, specific clauses are invoked that assign responsibilities clearly. The green light at this level is a signature, not a slogan. It protects engineers from carrying burdens that belong to institutions. Endurance thresholds guide civil protection. If energy on entry falls beneath an altitude-dependent line, emergency management prepares for sound and glass rather than fires. If it climbs above, a different checklist opens, one that coordinates siren protocols, hospital readiness, and advice to aviation. Around coastlines, another column considers water. Entry far offshore adds the possibility of waves that do not care for borders. Modeling teams provide footprints. Decision teams translate footprints into plane action. The way from model to message is rehearsed with the same respect as the way from ephemeris to launch. Trigger lines also keep teams from overreacting to allure. A handful of bright nights can seduce even adults into treating rarity as urgency. The framework resists through numbers. If probability sits in a narrow band at a long lead time, the instruction is to watch and sharpen rather than to build. If new data widens error instead of narrowing it, the instruction is to change weights, not to panic. If an outburst shifts the center of light, the instruction is to ask whether the center of mass moved at all before calling a crisis. That discipline keeps energy available for moments when thresholds are crossed honestly. Green does not exist in a single color. There is a green for data sufficiency, reached when models converge under different methods. There is a green for trajectory, reached when the intercept design carries margins against fault and weather. There is a green for hardware, reached when components pass vibration, heat, and vacuum. There is a green for governance, reached when the paper that authorizes risk is signed by those who must answer to citizens. Only when these greens overlap on a shared calendar does a mission earn a countdown. In that overlap, a planet practices composure. Abort lines are printed beside go lines. If a window closes during integration, stand down and preserve what can be preserved for the next window. If a new arc reduces probability beneath the level where intervention is justified, shift resources back to survey and analysis without defensiveness. If a fragmenting target renders a planned nudge unwise, pivot to reconnaissance and accelerate civil advisories. The instructions are written in advance, because disappointment should not be left to improvise. Resources are thresholds in concrete form. Funding arrives in tranches tied to milestones. A green light at an early milestone releases long lead parts and tooling. A green light later releases assembly and test. The scaffolding ensures that caution and momentum can coexist. People who build instruments and vehicles deserve a framework that respects their time. They carry the threshold culture into laboratories where metal, glass, and code are made to exist on schedule. In the end, triggers are a moral invention as much as a technical one. They prevent fear from driving choices that belong to evidence. They prevent pride from delaying choices that belong to responsibility. They distribute agency across desks, so that no single hand bears a weight it should not. Written plainly, they turn rare nights into lists that anyone at the table can follow without charisma. They turn green into a promise kept between a world and its watchers. When action is justified, it will be taken, and when restraint is justified, it will be honored. Physics becomes intimate when it meets tools built by hands. Equations that govern continents of vacuum must be translated into tolerances, parts lists, and guidance software that fits on chips. Momentum exchange is a grand phrase until it becomes a diagram of mass and speed with a box labeled bus and another labeled target. A small craft carries its velocity like a promise. On arrival, the promise is kept in a single contact that rewrites two trajectories at once. If the strike point lands in a region where ejecta fly mostly backward, the change in speed grows larger than the craft alone could supply. If the strike smears across a dusty slope or finds a pocket of void, the gain shrinks. Engineers work to outwit randomness by teaching cameras to paint the target with landmarks during the final minutes, locking a predicted boulder into the crosshairs so that the shock has purchase. Guidance, navigation, and control are the voice and hands of this plan. Star trackers and gyros keep a sense of self in the dark. Optical navigation harvests a dot and turns it into a shape long before resolution should allow it, using algorithms that match edges across frames and infer distance from arc, seconds, and time. During terminal approach, the craft must decide hundreds of times per minute which thruster to pulse to keep its path on the corridor that leads to a small, bright aim point. No radio loop can guide at that speed. Autonomy is not optional. The craft rehearses in simulation where fake rocks cast fake shadows, because the real ones will be lit from a sun that never changes its mind. An alternative to violence tries to be patient. A gravity tractor does not touch. It hovers near the target and uses its own mass to pull, maintaining position with thrusters that push away just enough to keep the distance steady. The tug is gentle, measured in newtons too small to feel in a human hand. Yet applied for months or years, it can move a rock by thousands of kilometers by the time an encounter would have happened. Holding station near a lumpy spinner tests the art of flying in a gravity field shaped like a pebble, with microplumes arranged so that they do not blast dust into a cloud that confuses sensors. Confidence in this method rests on navigation that can keep a specific distance from a specific point, while the point rotates into night and back into day. Between impact and tractor lives a family of ideas that push with light and gas. Ion engines can be aimed not at the craft's wake, but at the asteroid itself, the exhaust forming an invisible broom that sweeps momentum into the surface without touching it. The beam must remain clean and constant, and leaks must not backflow in a way that changes thrust direction. A standoff laser can ablate a patch of surface, turning dark rock into a plume that pushes the remaining mass in the opposite direction. Here, beam quality is the soul of the plan. Energy must arrive in a tight circle despite distance and jitter. The plume must not return to coat optics. Mirrors must shed heat or be cooled until the lattice of their glass does not bend. For both concepts, the passive environment turns active. A target that seemed inert becomes a thruster, using its own material for propellant. Nuclear devices occupy a separate conversation, where physics speaks loudly and policy speaks louder. A detonation positioned near the surface floods it with X-rays and neutrons that bake a thin layer into plasma. The expanding shell pushes the rest in a small but decisive way. Standoff distances are chosen to maximize momentum transfer and minimize fragmentation. Yields are calculated to be sufficient but not extravagant. In every case, attention to the arc of debris is paramount, because fragments carry their own risks if they are large and energetic. The technique promises power, but requires consent across borders and careful thought about failure modes. It belongs to a toolbox used only if other tools cannot meet time or mass constraints. Every method must fold itself into the shapes allowed by launchers and calendars. Transfer trajectories are not suggestions, they are the narrow paths through which mass and time can travel together. Designers draw maps in energy units against dates and look for islands where a feasible vehicle can depart and arrive with propellant in its tanks and confidence on its charts. If a target requires a high approach speed, the impactor benefits. If it requires a delicate slow pull, the tractor suffers. Windows drift, planets move. A late start can turn an elegant plan into one that burns too much fuel or misses by geometry alone. Ejector risk is an engineering constraint on top of a science prize. A fast strike sculpts a cloud that can sandblast any escorting witness or any follow-up vehicle that arrives too soon. Shielding can save electronics, but not optics. Keeping distance protects the witness and robs it of detail. Creative orbits that loop above the poles or skim across the terminator can trade dust for geometry. Instruments that see in non-visible bands can read heat through haze and ultraviolet fluorescence through a fine fog of grit. For slow-push concepts, plume impingement from station-keeping thrusters can leave soot on solar panels or alter the very surface a tractor tries to influence. Thruster placement becomes a map of forbidden cones and allowed arcs. Reliability becomes a personality in these designs. Each subsystem faces a job it cannot refuse, and the chain is only as strong as the least redundant link. Cameras must not saturate at the last approach or the guidance falters. Tanks must feed reliably at millinewton throttle or a hover turns into a drift. Antennas must swap from high-gain to low-gain modes without drama as the geometry of Earth and Sun changes. Fault trees are written with attention to natural failure and to the special failures that the method invites. A laser mirror can foul, a tractor can drift into a collision. A kinetic bus can fragment a target into a form that complicates later encounters. Each risk earns a mitigation that is tested until it is boring. Calibration and testing on Earth are not perfect mirror images of space, yet they build the muscle memory that keeps missions honest. Target boards in vacuum chambers serve as stand-ins for asteroid textures. Plumes are modeled with gases that behave like expected ablation products. Gimbals practice the sweeps that terminal guidance will require. Time delays are injected into control loops to mimic the lag between sensor and thruster, then increased past expected values to see where the loop becomes unstable. The point of rehearsal is not to predict every quirk. The point is to prove that control systems degrade gracefully when reality withholds cooperation. Politics enters through risk appetite and timelines. A mission that asks for a launch within a year of discovery must convince many hands to accelerate funding and to accept that some options, such as bespoke parts, will be replaced by off-the-shelf choices. A long warning favors slower, elegant methods, but requires the patience of administrations that change. Agreements about data sharing and decision authority are written in peacetime and read in urgency. Insurance markets, public expectations, and the interests of many nations meet in the narrow corridor between knowledge and action. Engineers prefer clocks and numbers. Decision-makers must add obligations and promises. Ethical design shapes even the orientation of a strike. A nudge that moves a possible encounter away from one region may increase a tiny probability for another. Maps are drawn with contours that show not just where safety grows, but where responsibility shifts. The craft's flight profile can be altered to minimize these transfers, accepting a smaller change in speed if it yields a more equitable distribution of risk. Legal frameworks require consent from those whose risk budget is touched. Consent may require transparency that slows a schedule. Balancing these factors is not an afterthought. It is a core requirement that keeps humanity's tools worthy of the world they intend to protect. Education and outreach are engineering in a different register. An informed public is a structural member in the architecture of readiness. When people understand that a change of millimeters per second applied years ahead can translate into safe separation measured in Earth radii, the choice to build and launch becomes easier to explain. When a map of probability lanes is drawn without hyperbole and with clarity about dates, the patience needed for slow methods gains a foundation in common sense. Engineers will build what budgets allow. Budgets are shaped by trust. The stories told by practice carry into design. A mission that changes a path by a fraction grows more potent when paired with a survey that sees far ahead. An infrared eye in space helps a kinetic impactor pick the right day. A radar on Earth turns uncertain masses into numbers that shape tractor durations. The landscape of systems is not a set of isolated projects. It is a network where the failure of one node is softened by the presence of others. Redundancy is not waste, it is resilience. At the core of all these choices lies a simple constraint. The clock never stops. Celestial mechanics writes a relentless schedule for opportunities and for risks. Engineering matches pace by breaking audacious goals into actions that can be tested, financed, and flown. The artistry is to preserve elegance while accepting compromise, to keep the physics pure while letting human needs into the room. Momentum exchange, ablative plumes, gravity gradients, and governance meet and form a braid strong enough to hold a plan through weather, delay, and doubt. A world learns to act at the scale of stones and light, and in that learning finds a strategy that is neither war nor wish, but stewardship turned into practice. Rare events live in the corners of plots where axes meet limits. A graph might carry most of its weight in the middle, where averages lounge and expectations feel at home. Far from that comfort, thin tails stretch toward outcomes that steal breath without asking. Nature places treasure and trouble in those tails. Oceans remember them in tsunamis that visit once in centuries. Atmospheres remember them in storms with names that retire. The sky remembers them in rocks that arrive with energies tidy equations can compute, and human senses cannot imagine. Preparation is not worry for its own sake. It is the mathematics of kindness applied to the arithmetic of risk. Fat tails earn attention because the chance of harm declines slowly instead of falling off a cliff. A distribution with a generous tail will offer a small but stubborn probability of events large enough to alter calendars and maps. Planetary impact risk wears such a tail. Most incoming stones are grains that sketch brief green lines on summer nights. A few are houses that flake into sparks above cold forests. Fewer still are mountains that would turn seasons to ash. The low probability of this last class does not excuse inaction. It demands tools that can stretch across decades, and that can be taught to generations who will inherit responsibilities as surely as they inherit language. Decision-makers borrow from Bayesian habits, updating beliefs as facts accumulate. A faint smear on a survey frame becomes a chain of positions. A fit becomes a corridor. The corridor shrinks, and the posterior probability migrates towards safety or concern. In this rhythm, the cost of a false alarm is weighed against the cost of silence. Overreaction wastes time and trust. Underreaction risks the only world anyone knows. The calculus treats information as a commodity that can be bought with telescope hours, radar energy, and the effort of coordinating eyes across nights and latitudes. The price of that information is measured against the reduction of uncertainty it purchases. In a universe where early knowledge is leverage, the balance often favors buying more. Extreme value theory is a language suited to such bargains. It asks not how often events occur, but how large the largest can be given enough time to wait. Civilizations endure by taking long views, by asking what a century might bring, and by preparing for the century's unkindest hour while it is still twilight. Insurance markets learned this through floods and fires. Planetary defense learns it with orbits and albedos. The shape of the tail matters more than the median, because the tail holds the futures that would bend history. Fear has a way of slipping its leash when tails become the topic. The antidote is not dismissal, but literacy. A chart that shows probability per year alongside consequences measured in energy and footprint can bring a mind back to clarity. A 1 in a million chance wears a different color when the million years available are not a thought experiment, but the interval over which kin have carved symbols into stone. Clarity does not crave melodrama. It asks for scales and dates presented without swell or whisper, in units that admit conversion to shelter plans and launch calendars. Black swans in the sky are not unknowable, only hard to see early. The system to find them grows by increments. Each new survey reduces the space of surprise. Each test teaches how tools behave in the edge cases, where ideas either prove durable or confess their limits. In this accumulation, rehearsals begin to resemble mobilization. Teams drill flight operations. Warehouses track components that must move quickly if a window opens. Agreements sit ready for signatures that would turn principle into action. The optics of such readiness can invite quick slogans about war in the heavens. The reality is quieter. The machinery is not pointed at a foe. It is threaded through with checks, transparency, and an aversion to secrecy that would poison trust. Uncertainty can be deep, the kind that stubbornly refuses to narrow even as data grow. Models with different priors can cling to different futures. The remedy is not to declare stalemate, but to invest in measurements that discriminate. A polarimetric signature that reveals grain sizes will favor one mechanism of acceleration over another. A well-predicted occultation will slice a silhouette that confirms or rejects an elongated shape. A follow-up spacecraft, small and fast, can fly through a coma and deliver dust counts that end an argument. Each such measurement is a coin spent to buy decisions that are calmer because they are grounded. Human minds tilt towards salience. A bright streak across a city sky that breaks windows feels more real than a paragraph about a body that passed at a comfortable distance in the dark of a winter sea. The bias cannot be scolded away. It can be engaged. Exercises include communication drills that write messages designed to survive compression into headlines. The line between reassurance and candor is found in drafts that avoid furniture polish and also avoid irony. A population that understands why a low probability can justify high readiness becomes a partner in the enterprise rather than an audience held at arm's length. Some worry that practicing response will invite hawks who seek mandates for other games. The worry is not naive. Power is a magnet for ambition. To guard against it, planetary defense braids itself to scientific openness. Data are public by default. Interagency liaisons include civil society and universities beside military logistics, because runways and tracking networks sometimes live under the same roofs. Procurement emphasizes dual-use tools that make science better, even if they are never called to deflect anything. Infrared surveys that find warm stones also find near-Earth comets that hold chemistry lessons. Radar that paints an asteroid improves knowledge of gravity fields that serve navigation for missions of all kinds. Such dual utility makes a budget easier to justify and removes appetite for secrecy that would distort the mission. Risk is never only external. A mission designed to nudge a body must consider the small probabilities that the nudge fails, or that it fragments a weak target in an unfriendly way. Formal frameworks exist to evaluate these outcomes in expected value terms, but they wear human faces. Maps are drawn with lines that show how a deflection shifts probability from one corridor to another. Consent is sought from those whose risk budget changes color during the maneuver. The habit of obtaining such consent becomes a protection against using the mission language to decorate unrelated ventures. The ethic is simple. Tools exist to reduce shared risk, not to concentrate it. Precaution needs a counterpart in proportionality. An exercise might reveal that a given scenario would cost $1 billion to mitigate, and that the probability fails to rise above a threshold that justifies that spend. A mature system can decline with grace and redirect funds to surveys and labs where the same money will buy a larger reduction in the tail. The virtue is not hair shirt denial. It is stewardship measured against finite resources. In the long game, consistency is strength. The public reads that consistency as honesty and returns trust in kind. Time horizons stretch further than careers. Plans must be written so that successors can read them without translation. A long view argues for funding models that behave like annuities rather than like weather. Facilities that will serve for decades need more than a headline to exist. A culture that rewards maintenance, calibration, and patient iteration defends itself against fads that burst brightly and vanish. In that culture, the edge of fear is dulled not by neglect, but by daily work. The drills gain ritual. Rituals build memory. Philosophy enters where numbers meet meaning. A world that can divert a stone must ask what obligation it bears to places beyond maps. If a deflection reassigns a sliver of risk across an ocean, the language of fairness and consent has to keep pace with guidance algorithms. If the decision is to do nothing because the numbers do not justify motion, that too is an ethical posture that should be spoken aloud and written with the same care as the command sequences that would have burned propellant. Silence is not neutral. It teaches the wrong lesson about responsibility. Speculation is permitted where honesty is clear. The list of unknowns will shrink, but never to zero. An interstellar traveler might carry materials not seen in the local catalogue. An orbital corridor might intersect resonances that amplify small pushes into late surprises. A climate of solar activity might bias measurements at unfortunate moments. The response to such whispers in the margins is not panic but healthy paranoia. Build slack into schedules, build redundancy into sensors, build humility into language. Between anxiety and denial lives the narrow path of readiness. This is the edge where fear can be useful without becoming a tyrant. It is the edge where drills look like mobilization, because readiness borrows logistics that the military has already perfected, while remaining fenced by transparency and purpose. It is the edge where people who measure photons can ask for trucks and antennas without mortgaging their ethics. A blue world does not need to be paranoid to be prudent. It needs to respect tales that carry low probabilities and high consequences. It needs to keep pencils sharp, mirrors clean, and protocols awake. The reward for that posture is invisible. Nothing happens on most days. Children sleep through nights when a quiet satellite revises a corridor by fractions and a planner moves a green box on a calendar with no fanfare. The invisible reward is the point. A society built to survive its own luck is one that learns to love the acts that leave no scar. The rare day that would have been catastrophic becomes an ordinary day because enough hands treated possibility as a teacher rather than as a ghost. Empires keep calendars. Their days are carved into fiscal quarters, their years into plans thick with signatures, their decades into visions that pass from one administration to the next like torches. The sky does not keep their time. It asks them to stretch. Budgets written for roads and schools must make a small space for mirrors and dishes. Procurement laws built to buy vehicles and bridges must learn to buy wavelengths and covariance matrices. The request is simple in physics and intricate in culture. A world composed of nations must agree that vigilance of the heavens is not a luxury of the rich or a banner for the proud. It is a utility, like water and weather reports, that belongs to everyone breathing beneath the same vault. Funding cycles move by habit, and habits can be coaxed if they are given a story that holds. Surveys that sweep the sky each night are easier to defend when their value is written in the language of continuity. A line on a ledger becomes a set of eyes that never blink, a national contribution to a global nervous system that will still be watching when current custodians are gone. Instruments in orbit that read warmth rather than reflected light are easier to protect when their deliverables include lists of objects, not promises of drama. Lists soothe treasuries. They produce trends, dashboards, and public maps that turn numbers into civic knowledge. In this language, an empire can rationalize patience, and patience is what the sky demands most often. Military liaisons arrive because the infrastructure that hears faint echoes and tracks moving points already lives partly in their house. Radars that sweep for aircraft can spare time to paint a near visitor if schedules are clear and if goals are compatible. Optical tracking networks that know how to watch satellites through twilight can be taught to report a new kind of motion. The collaboration must be disciplined to stay gentle. Civilian science asks for openness. Security cultures prefer quiet. Agreements are written with clauses that enforce publication of orbital solutions and protect calibration data from vanishing behind doors. When it works, the partnership feels like a shared antenna pointed upward, rather than a siphon that carries science into secrecy. Shared radars, shared telescopes, and shared software form a mesh across borders that political weather cannot easily tear. Universities host pipelines that ingest observations from many nations and return ephemerides that anyone can compute and verify. Small observatories in far longitudes earn as much respect as grand domes because coverage matters more than prestige. When an occultation path crosses a country without a large observatory, local clubs fill a line of small instruments across fields and rooftops, turning volunteer energy into shape measurements that rival space missions in their precision per dollar. Empires learn to make room for enthusiasts because the sky rewards density of attention. Governance follows the attention. Offices are created to coordinate space surveys, planetary defense exercises, and civil protection messages. Charters are drafted that bind agencies to speak the same dialect when risk is discussed. A graph that shows probability is labeled in words that match across languages. An alert issued in one capital appears in another, with identical numbers and identical confidence intervals. The discipline prevents confusion when hours matter. It also prevents opportunists from recasting the same event into different tones for local advantage. A shared lexicon becomes a quiet treaty. Treaties of the older kind must also bend. Launch agreements include clauses that reserve a handful of windows for emergency missions not yet designed. Overflight permissions for tracking aircraft widen when an occultation path drifts across borders at short notice. Data exchange protocols are made resilient to political tension in the same way that humanitarian corridors are kept open during storms. The precedent is simple. A planet does not benefit from teaching instruments to carry passports. Empires that learn this lesson earn reputations that cannot be bought by parades. Industry sits at the table because innovation and supply chains live there now. Detectors are made by companies that must balance profitability with reliability. Launch vehicles are offered by providers who juggle commercial and national schedules. Ground stations are operated by consortia that sell time to many customers. Contracts weave through all of it, shaped by requirements that express scientific needs in procurement language. A statement that begins with comma subtraction ends with deliverables and warranty terms. When the contracts are written well, the market begins to treat skywatching as a stable sector, not a whim. Stability breeds capability. Education is the long fuse to everything that comes after. Curricula that include orbital thinking in middle school produce adults who can read a map of probability without anxiety or cynicism. Planetariums host evenings where planners explain how a corridor narrows as data accumulate, letting the public watch humility at work. Films and books avoid apocalypse to showcase stewardship. Story is not decoration. It is the medium that moves expectation across generations so that a survey telescope funded by one parliament will still be valued when the next one sits down. Empires rise and shift. Literate populations are the continuity that matters. The press is taught to love the middle of the story, not only the beginning and the end. When a new object is announced, reporters are invited into the cadence of measurement, the way a corridor thins, the way residuals straighten, the way a line on a chart turns from smudge to stroke. Headlines that celebrate harmless without trivializing the work are praised. Headlines that shout doom without numbers are corrected. Over time, a culture of coverage grows that treats the sky with the same gravity used for weather and earthquakes. The drama remains available to artists. Institutions prefer clarity. Ethics councils are welcomed early. They write guidelines for consent when risk is redistributed by a planned nudge. They outline how to compensate communities that must prepare for a drill or a predicted airburst. They specify who signs and who must be asked, not as a burden, but as a way to legitimate action that could otherwise be seen as arrogant. The presence of ethicists in planning rooms keeps power from performing monologues. Citizens hear that the guardians of their sky know how to ask and how to listen. In such hearing, the temptation to borrow planetary defense language for unrelated ambitions loses its charm. Archives serve as both memory and armor. Every observation, fit, and decision is stored in a way that can be audited. Code used to reduce data is published or escrowed, so that later minds can reproduce conclusions. When a corridor widens or narrows, the plots remain, a breadcrumb trail through uncertainty that anyone can follow. These archives are a defense against revisionism as much as a resource for scholarship. Empires tempted to edit yesterday to flatter today find fewer shadows to hide in when data are commons. The sky demands redundancy rather than ornament. Two surveys with different designs, one chasing thermal glow and one mapping reflected light, reduce bias in each other. A network of small telescopes reduces weather risk that would haunt a single giant. Communications platforms are made resilient against storms on Earth, and storms on the Sunday fiber is paired with satellite links. Generators sit quietly near domes and dishes. Practice runs include simulated failures not to humiliate, but to habituate teams to the reality that machines fail, and that calm in the face of failure is a cultivated skill. Crisis reveals character, yet character is built in quiet. A successful planetary culture borrows the best habits from disciplines that learned under pressure and sheds the worst. From medicine, it borrows morbidity conferences where errors are analyzed without shame and lessons are shared. From aviation, it borrows checklists that move minds from panic to procedure. From weather services, it borrows non-sensational tone paired with direct advice. It declines, politely and firmly, the appetite for triumphalism. The sky does not tolerate swagger. It accepts diligence. Injustice still happens at ground level, while eyes point upward. It cannot be ignored. A project that erects domes on sacred hills without consent poisons the very trust planetary defense requires. A contract that excludes smaller nations from data turns protection into privilege. To answer the sky honestly, empires must practice respect on Earth. Consultation slows schedules. Inclusion complicates governance. The reward is legitimacy. Without legitimacy, instruments become totems rather than tools, and drills become theatre. With it, a community of many languages can say we in a sentence about a comet and mean it. The verdict the sky seeks from empires is not a pledge of strength but a proof of care. Do budgets endure when headlines do not? Do institutions share more than they hoard? Do militaries lend infrastructure without demanding a narrative that turns stewardship into strategy? Do schools teach orbits with the same seriousness as arithmetic? Do journalists accept the slow dignity of narrowing error? Do citizens see their taxes return as instruments that serve all and as messages that neither inflame nor condescend? The answers accumulate one policy at a time, one shared observation at a time, one consent form signed in a town hall at a time. In the end, a planet learns to defend itself by cultivating a temperament as much as a toolkit. The temperament is patient, curious, and transparent. It asks its empires to be stewards instead of owners, gardeners instead of hunters. The sky answers such temperament with cooperation. Clouds part often enough, data flow clear enough, windows open wide enough. A civilization that keeps its promises to itself finds the patience to keep promises to the future. In that patience, the instruments will turn, the radars will hum, and the calendars will bear a small recurring line that reads, "Simply watch." The line will outlast parliaments and uniforms. It will belong to the world. The question travels like a rumor that refuses to tire. Why do quiet deserts glow at night with generators when the visitor is labeled harmless? Why do tables fill with maps when the path clears the blue world by a margin wide enough to cradle comfort? The answer is not a secret, nor is it drama. It is a posture. It is the stance of a species that has learned to place tools between itself and chance, and to keep those tools clean even on days when luck is kind. The posture is practiced without applause. It turns headlines into background and keeps background from becoming a crisis. A small body from another sun glides through dark like a seed that wandered beyond its garden. It is measured with affection disguised as discipline. Photons are weighed, periods traced, colors teased until they confess their chemistry. The verdict is safety. The object will pass at a distance that leaves tides untroubled and windows intact. The verdict does not cancel work. It refines it. Measurements sharpen, not to feed worry, but to deepen knowledge and to teach instruments how to speak more clearly when a future visitor refuses to be so gentle. The labor turns from a guard posture into a study session, and the study session enriches the next guard posture. In this loop lives the answer. There are names for this habit: prudence, stewardship, the long view. They fit, but the feeling behind them is older than names. In caves, ancestors watched storms gnaw at the edge of their world and learned to step back before waves arrived. Farmers read the green and the brown and stored grain for winters that might last beyond predictions. Sailors learned to strike sail at the smell of iron in the wind. The same reflex moves now through keyboards, mirrors, and antennas. The object is different. The gesture is the same. It honors fragility without kneeling to fear. Readiness is often mistaken for hostility because it borrows logistics from institutions that once trained for human conflict. Trucks, radars, secured lines, flight readiness reviews, checklists built to stop error from multiplying. The surface looks martial, the content is not. The trajectory is a curve in empty space, not an intention. The launch is a machine for exploration or a demonstration of gentle force, not a threat. The network is a commons of data rather than a scaffold for victory. To mistake these for drums is to confuse rhythm with motive. Silence makes a good teacher in this craft. When a new object is flagged, the night often gives no sound, no flash, no reason to quicken the pulse beyond habit. That silence is the space into which a civilization can pour practice. The measured language of reports, the regular tempo of telescope loops, the care with which one team hands a file to the next. In the quiet, an arc lengthens, a corridor thins, and a word like harmless sits on a stronger shelf than it would without effort. People sleep through the lesson. The sky records the grade anyway. Even if the visitor bore more energy, the essence of the answer would not change. The tools would step forward one notch. Surveys would turn nights into a cadence of more intense coverage. Radars would hum longer. Planners would write schedules with less margin and more resolve. If an intervention became necessary, it would be executed with a minimum of spectacle and a maximum of numbers. The act would be small in physics, a few millimeters per second painted onto a stone, and large in meaning, a sentence added to the grammar of how a world negotiates with nature. The visitor that prompted this question is a mirror as much as a body. In it, a planet sees itself measuring, debating, practicing, and deciding. It sees its institutions capable of calm in the face of a tension that could turn them theatrical. It sees its public learning to read graphs without panic, to ask good questions, to accept updates that turn worry into boredom with relief rather than cynicism. The mirror is kind because it reflects effort that has matured. The kindness is earned. Some stand beneath the stars and resist the urge to name, to catalogue, to intervene. Their reverence is not misplaced. Wonder needs no justification. Yet wonder is not offended by care. The act of preparing does not profane the sky. It dignifies it. Instruments are not fences, they are instruments. Their music is data played into understanding, then into policy, then into drills that leave no scorch mark. The heart behind them is curiosity, braided with responsibility. Elsewhere, a student tunes a code that will subtract coma more honestly. A technician on a cold ladder wipes a lens with a motion born of muscle memory. A teacher sketches an ellipse on a whiteboard and explains eccentricity with the patience of someone who believes that today's lesson will be tomorrow's fealty to reason. A child looks up at a graphic on a screen where a blue sphere and a white speck cross without touching, and learns that care can be quiet. None of these scenes demand a myth. They ask only that a world attend to itself. The language of an answer can become ornate when the subject is grand. The better language is modest. This is not preparation for war. There is no enemy, no territory to claim, no glory to chase. There is only a field of stones and ice moving in an old dance and a fragile biosphere that now understands the steps well enough to avoid being tripped. Readiness is a choreography lesson. It is a rehearsal that hopes never to perform in full. Its trophies are nights that end uneventfully and mornings that carry no special page in the news. A culture matures when it can carry two thoughts without letting them collide. The first is that the visitor is beautiful, a relic from elsewhere, a chance to taste chemistry seasoned in a different oven, a shape carved by unfamiliar seasons. The second is that margins matter, that measurement is a form of respect, and that practice is a form of love. Together, they make an answer to loud questions that will not be satisfied with quiet words. The answer stands anyway, steady as a plot with error bars that have finally settled. The practice will continue, not out of paranoia, not for vanity, and not to feed any appetite beyond the desire for a long, ordinary future on a lively planet. Instruments will be built and retired. Software will be written and rewritten. Teams will learn each other's cadences and then hand those cadences to younger hands. The sky will do what it does. Objects will pass in peace. A few will whisper closer. The reflex will hold. The drills will open their folders. The decisions will be made without tremor. If called to give a single sentence and nothing more, the people at the tables would say the same thing. The visitor is harmless. Readiness is not a contradiction. It is the habit that keeps harmless true. In that habit, the world finds its grace. Poetic wind down. The night folds itself like paper, edges meeting with a crispness that invites one more crease. On a horizon seen from deserts and balconies, a faint traveller slides into the dark between constellations, never knowing that a species watched and learned and kept its tools awake for its passing. The sky does not record gratitude, yet gratitude rises anyway. A quiet warmth that flows from screens and charts toward a silence too large to notice. It is enough that gratitude exists. A planet turns, and with it turn observatories, antennas, and minds. The turning is a lullaby. Lights in control rooms blink to slower tempos. The generators quiet. Doors click. On kitchen tables and lab benches and dashboards, small notes lie beside empty cups with the handwriting that belongs to people who make careful days. The notes read things like adjust exposure and reweight residuals and call at 7:30. None of them read salvation. All of them read stewardship. Clouds begin to comb sunrise into the first pages of another ordinary day. In parks and classrooms, in fields and subways, lives resume their loops. The work that guarded those loops is invisible and perfect in its invisibility. No monument is needed, no speech. The monument is a sky that continues to be a dome rather than a ceiling. The speech is a whisper traded between colleagues that says goodnight and means keep watch. The traveller goes on. It will cross a border, no charters drawn, and enter distances where even the most ambitious instruments let go. It will carry a faint dusting of stories from this system to a darker lane between stars. Somewhere, ages from now, perhaps no one will be there to measure it. The absence of an audience changes nothing. The act of care has already occurred. That is the story. That is the answer. End of script. Sweet dreams.